What does it mean, in the dark arithmetic of space, to stumble upon something that was not supposed to be there? To enter a volume of the cosmos marked on no chart, and have the instruments baptize the void with a single bright exception, a point of light that answers the ship's probing like a mirror waking to speech. That question hangs at the beginning of every true exploration, not where to go, but what to do when the map proves insufficient. The mission had been simple in its ambition and stubborn in its humility. A research vessel, built to be patient and precise rather than fast and flashy, had been dispatched to chart an unremarkable seam of the galaxy, a tract of space whose common coordinates contained only thin gas, distant, faint stars, and the statistical expectation of nothing remarkable at all. The crew's mandate was to render the unknown legible, to sweep their sensors across the darkness and translate absence into data. Their task was not discovery for discovery's sake, but the slow accretion of certainty, to replace blank space on a ledger with numbers. This was an exercise in epistemology as much as in engineering. The ship carried instruments designed to interrogate the universe at many scales. Wideband scanners that listened for the whisper of radio frequencies, LiDAR arrays that sketched silhouettes with laser pulses, gravity gradiometers that felt the infinitesimal tug of hidden masses. The crew's routine, rehearsed on simulators and in quiet pre-flight briefings, was a choreography of calibration and patience. They adjusted their orbit around the target region in micro increments, angling their sensors, waiting for the background noise to settle. When they tweaked their trajectory, turning the vessel to bring a different set of sensors to bear, the radar signature returned, a thing that did not fit any preloaded model. On the radar screen, it appeared as a patch of specificity amid expected uniformity, a broad, reflective object catching and redirecting light with a geometry that spoke of edges and scale. It was large. Its return echoed across multiple bands, its albedo anomalous, as if a body of some density and composition had been arranged to throw sunlight back like a polished blade. For a few suspended moments, the ship did what any modest machine taught to be cautious would do. It gathered more data. The scanners tightened their focus, emitting a higher cadence of pings and pulses. The LiDAR painted a lattice of points into the void, each ping rebounding as a tiny, honest fact. The spectrum analyzers widened their aperture, examining the reflection across wavelengths, seeking fingerprints that could betray mineralogy or manufactured surfaces. Thermal imagers looked for heat. Gravimeters checked for the subtle curve of space-time that a mass of that size. The measurements converged on a sense of contradiction. The object reflected visible light with surprising intensity, almost crystalline. Its thermal signature, however, was enviably cold. It shed almost no heat at all. Its radar cross-section suggested facets rather than a diffuse cloud. The gravimeter, after a long and patient integration, detected a faint but definite mass, consistent with a body larger than a moonlet yet smaller than a planet. Its orbital elements, if it had orbital motion at all, were not easily reconciled with the surrounding stellar currents. It appeared to be present, stationary. From a human vantage, the discovery conjured a cascade of emotions that the ship's design had not entirely anticipated. The crew, trained to remain analytically detached, felt a quickening in their chests that modern machines could not compute, a version of awe that was partly scientific excitement and partly the older, more elemental hunger to know. There was the anticipatory tension of a lab when a measurement refuses to fit the null hypothesis, the thrum of possibilities from mundane. A rare comet fragment, an unusually reflective asteroid, to the extraordinary. Yet the prevailing reaction, beneath the sharper edge of curiosity, was a small, persistent humility. In hours and days of quiet checks and recalibrations, the team had convinced themselves that the universe would yield in time to careful measurement. But the moment the radar returned that bright, precise echo, the crew understood they had designed their mission to encounter the unexpected, and the unexpected had arrived with a dignity that demanded patience, not spectacle. They fed the sensors more questions. The ship's arrays made modest adjustments, lower power pulses to avoid perturbing the object, longer integrations to reduce noise, spectral sweeps to gather compositional hints. Each new set of data painted a richer, but not simpler, portrait. The reflectivity varied subtly across angles, suggesting surfaces oriented in ways that hinted at structure. Polarization measurements indicated alignment beyond what random ice or regolith would present. Trace emissions at particular bands whispered of alloys and doped materials. Signatures that could be natural in rare contexts, but which also mattered. There was, too, a temporal element. The object's reflected light pulsated with a regularity that defied being purely stochastic. The ship recorded micro-variations, each transit, slight changes in intensity that formed repeatable patterns over hours. These patterns hinted at rotation, or at some engineered modulation of surface properties, or perhaps at a periodic interaction with surrounding microdebris. Each hypothesis bent the search in a different moral and operational direction. If natural, then it was an unprecedented natural phenomenon. If artificial, then it was a relic, a mission. As the narrative voice of the mission, the telemetry that summarized and the logs that recorded grew longer, the crew's internal sense of scale shifted. The discovery was not merely an intrusion into their map, it was an invitation to think in deeper time. What was this object's story? Had it formed here, where no models predicted such an arrangement of matter, over billions of years of dust and collision? Or was it the remnant of a process whose agents no longer lingered, a broken monument, a husk of intent from a civilization long erased by entropy and catastrophe? The mere possibility of artificial speculation matured into operational caution. The vessel adopted a holding pattern, a precise ballet of station-keeping maneuvers done to maintain scientific objectivity while minimizing any chance of disturbing whatever equilibrium the object occupied. Small jets whispered sympathetic corrections, gyros hummed like the heartbeat of a careful animal. The crew's movements within the ship, though unseen, were methodical. Instruments were cleaned of cosmic ray glitches, cross-checks executed, and redundant teams took turns reviewing the same data with fresh eyes. A culture of reverence threaded through the task. No hasty conclusions, no premature naming. There are moments in exploration where facts proliferate faster than narrative can keep up. A new spectral line appears, a geometry reveals an unexpected shadow, a radio burst echoes and then is gone. The ship's communications log recorded a series of such micro-events, each one a seed of further inquiry. One spectral sweep suggested crystalline lattices consistent with silicates. Another, moments later, hinted at reflective coatings at sub-millimeter scales. Micrometeoroid impacts, tracked across days of high-sensitivity detection, suggested a debris field. The kind of environment that could fracture and in the hush that accompanies the accumulation of small suggestive facts, the crew felt their own temporality more acutely. The ship was, by design, a temporary reader of a much older text. Its instruments would be updated, its crew would rotate, and in geological or cosmological terms, its presence was an instant. Yet for the human minds aboard, the discovery reoriented their sense of continuity. They were not merely collecting data, they were peering at a thing that might outlast cultures and which might carry within its alloys or ice the echo of day-to-day life that no archive had preserved. Here the narration shifts in quiet voice to the broader lens that documentary thinking loves, the thought that every artifact, whether built by hands or by the slow hand of physics, is an argument against oblivion. A reflective body in a dark expanse is a statement that states of being, whether geological, biological, or cultural, can be frozen into matter and sent onward. The ship and its crew, in this sense, were both heirs and archivists. They were positioned to read and to remember. There were procedural decisions to be taken. The mission rules set clear thresholds for escalation. Anomalous finds triggered a cascade of protocol, from extended data capture to notification of central command. Yet within those rules, the crew exercised judgment. They extended observation windows, delaying the ritual of transmission to the distant bureaucracies until they amassed enough context to present more than a tantalizing fragment. In their waiting, they cultivated a discipline of silence. Each new reading was logged, described, compared to known analogues, and the discrepancies with the ship's instruments, in their tireless way, continued to tell a story that the human mind translated into the language of origin and meaning. There were hints of geometry, shadow patterns that repeated with an almost architectural regularity. There were materials identified that suggested low-energy manufacturing processes, not the sudden signature of active construction, but the slow, deliberate shaping that could be achieved by thermal cycling and directed abrasion over enormous timescales. Yet other signatures remained recalcitrantly alien, emission lines at frequencies that did. Against this catalogue of measurements, the most haunting possibility remained that the object might be the last visible trace of a civilization extinguished by the indifferent calculus of time. The idea could be tender and terrible in equal measure. Civilizations in speculative thought are both brief and grand. They leave behind artifacts because artifacts are second-order time capsules, durable in a way that ideas and songs rarely are. A polished surface, shielding an interior, could survive long after the voices that conceived it are dust. To find such a relic would be to witness this speculative axis between the natural and the artificial, between contemporary accident and deep-time legacy, is precisely where documentary narrative hums with the most electric life. It refuses to reduce the discovery to a soundbite. Instead, it lingers on the moral and philosophical edges. If the reflective body was a monument, what had been its purpose? Was it a marker, a navigational beacon, a funerary mound cast into the darkness, or a piece of mundane infrastructure that had simply outlived its makers? Each possibility reframes the human relationship to time, and yet, amid these grand reflections, practical realities reassert themselves. The ship had to decide how much risk to assume in the pursuit of clarity. Close approaches promised higher resolution data, but increased the danger of collision or of disturbing an environment that might itself be fragile evidence. Remote sensing could only carry them so far. Scientific curiosity pressed forward, but a conservatorial ethic pressed as well, to harm less, to learn more through patience than by force. The radar's discovery had created a new focus for the mission, an axis around which future decisions would revolve. It had also quietly transformed the crew's inner landscape. Their work would now be a test of humility before the cosmic unknown, of restraint when confronted with potential treasure, of reckoning with the possibility that they were not only explorers but caretakers of a history far older than their institutions. In the logbooks, later entries would mark the start of a long campaign of observation, scheduled sweeps, modelled scenarios, risk assessments, and the slow accrual of hypotheses weighed against data. For the narrator, the moment would remain a hinge, the clean, bright ping on the instruments that interrupted routine with a rumour of depth and complexity. It was, in essence, what exploration had always been at its best, an interruption that invited thought, discipline, and a kind of awe that did not need to be loud to be profound. The scene closes on a meditation rather than on an action. The ship holds its station. The reflective object continues to return light according to its inscrutable geometry. The crew watches, listens, and records. In that patient vigil, there is a recognition that some discoveries are not immediate gifts, but slow unearthings. The universe, in its long and indifferent time, keeps many secrets wrapped not in silence, but in slow revelation. The first glimpse, the unplanned discovery, is merely the first page of a book whose chapters will be written in spectra and trajectories, in blackboards of data, and in the... Above all, the discovery reframes a familiar humility. Compared to the deep timescale of planetary and cultural rise and fall, any human mission is brief. Yet within that briefness, humans have the capacity to notice, to wonder, and to remember. The reflective body in that unmapped region of space had, in a single radar return, extended an invitation across epochs. The crew, and the observer telling their story, accepted. They would read patiently, like archivists of the cosmos, keeping watch so that whatever narrative the object held would not. What does the mind do when it meets a place that, officially, does not exist? Not in the soft sense of surprise, the casual surprise of a new comet or an unusually bright nova, but in the harder sense of institutional absence, a coordinate that produces no archival lineage, no catalogue numbers, no transit history, no dataset to anchor it to prior human knowing. The question is at once practical and philosophical. Practically, how does one approach something one cannot check against experience? Philosophically, what is the obligation of the present toward a thing that arrived? No data existed in humanity's astronomical database for this planet. That sentence, flat and bureaucratic, contained an emotional geometry. It meant the object had not been spotted, not been logged, not been passed through the slow filters of surveys and peer review. It meant there were no discovery notes, no notes on parallax that could deliver distance with ease, no archival spectrum to reassure the analyst that this was, at most, an unremarkable rock. The blank space in the database behaved like an accusation. Either the sky had been previously blind, or something here was new in the terms that mattered to approach to the target. The vessel adjusted its attitude. It was a procedural action. Micro-impulses calculated by a 1,000-line orchestration of code and caution. Thrusters fired in tiny, measured breaths that nudged inertial frames, reaction wheels whispered compensations, and the long shadow of a solar array trimmed its angle by fractions of a degree to preserve comms bandwidth. The adjustment was not theatrical. It was the choreography of restraint, the kind of movement that engineers practice until it feels like ritual. Sensors switched modes like instruments on a turntable, from broad, sweeping sweeps that had first discovered the reflective anomaly, to narrow, high-fidelity peaks that would map nuance. LiDAR arrays reoriented, narrowing the cone of emission into a denser grid. Radar pulses were shortened and hardened to avoid saturating receivers or generating spurious echoes from the object's reflective planes. The science team favored a conservative corridor of approach, one that limited relative velocity, reduced cross-track error, and kept the ship's signature small. Every adjustment carried a competing arithmetic. Closer, on the bridge, and in the observation bay, screens recalibrated. The planet, if planet was the right word, bled into view, not as a full globe at once, but as a geography of suggestion. The first high-resolution frames arrived as a wash of edges and depth maps, a surface scored into great fissures, seams that opened like the pages of an old book. These were not hairline cracks, but canyonous rents that yawned deep enough to capture sundown and hold it. Between the rifts, plains lay folded with striations as if tectonics had worked with a patience that mocked the briefness of the observer's tenure. Dust plumes rose from fissure rims, delicate, pallid columns that curled and dispersed under local wind patterns. In some places, a faint mineral light shimmered along edges. Not the raw white of fresh ice, but a bruised metallic sheen that suggested either concentrated ores or surfaces that had been abraded and then polished by a slow, unseen hand. In other areas there were darker patches, as if something had been exposed and then blackened by a process hard to name. The palette was not random. It hinted at cycles, at episodes of activity, and at histories that folded over themselves. The planet's silhouette carried other anomalies. There were points of high reflectivity, bright knots like polished shields that contrasted with areas of low emission, almost surgically dark. Shadows traced into the chasms with such depth that the ship's imaging systems had to compensate for dynamic range, revealing not just relief, but a sense of layered architecture. At certain longitudes, linear features aligned with an unnerving regularity. Margins of equal width, ridgelines that marched like concordant seams. Pattern, in this context, is an invitation to instrument readings deepened the mystery. Thermal maps painted the surface extremely cold, a body that held little residual heat. Yet pockets of warmer radiation flickered at the fissure mouths and at certain bright patches, sometimes in pulses that suggested outgassing or transient electrical activity. Spectrometers, sweeping across infrared and visible bands, found signatures consistent with silicates and complex salts, but also narrow emission lines that did not fall neatly on known isotopic charts. Polarimetry measurements showed alignment in surface scatterers that would be improbable in simple regolith. There was a tactile quality to these data. The crew, as much algorithm as human in this phase, read the numbers like a cartographer reads a coastline. Lines that repeated, spectral lines that hummed at fixed frequencies suggested internal structure. Gravimetric sensors measured a mass distribution inconsistent with a homogeneous body. There were densities concentrated in ways that cast gravitational gradients, tiny but measurable, that the ship's long integration times were finally able to tease out. The gravitational maps sketched anomalies, mass concentrations that correlated with some of the more reflective. The human element threaded through every technical detail. The mission team operated with cultivated calm. They were trained to translate wonder into procedure. Still, there were ineffable moments, a communal inhalation when a new image populated the screen, the subtle shift in posture when a data point refused easy explanation. These were not theatrical beats, but the honest small physics of emotion when knowledge meets surprise. The scientists and engineers aboard felt, in their own ways, both the thrill of discovery and the pressure of responsibility. The ship had been sent to translate the unknown into ledger entries, and decision-making spread into long panels of calculated patience. Mission protocols required certain thresholds to be crossed before dispatching a signal to Earth, a cadence of validation intended as both safeguard against false positives and as a defense for the mission's reputation. Here, however, the team delayed the broadcast. They elected to gather a longer string of observations to build a narrative robust enough to survive the scrutiny of distant committees. This delay was moral as much as procedural, to present an account not of impression but of corroboration. The delay felt to them like an ethical posture. Their chosen methodology was conservative in one sense and expansive in another. They extended their observation geometry, viewing the planet across multiple phase angles, tracing phase curves to extract roughness at many scales. They shifted spectral windows, seeking to move beyond surface composition into microtextural analysis. They employed time-lapse sequences, allowing the planet to reveal change across hours, gathering a sense of diurnal or episodic rhythms. And above all, they kept distance. Close enough to coax data into fidelity, distant enough to avoid perturbing delicate equilibrium. Small scenes became protracted rituals, the careful recalibration of a LiDAR array after cosmic ray interference, the midnight hour debate over whether a particular bright node was a natural metallic seam or an exposure of processed material, the quiet satisfaction when a cross-check between radar and gravimeter resolved a positional ambiguity. Each such action was a small stone in the construction of meaning. They expanded what could have been a terse observation into a patient, layered report, one that acknowledged uncertainty as an ingredient rather than a defect. The planet's surface, in these drawn-out examinations, narrated deeper possibilities. The fissures, observed at different wavelengths, showed horizons where underlying strata reflected different ages, older, more thermally altered layers overlain by fresher deposits. Micron-scale anomalies suggested abrasion at scales too uniform for random meteoritic wear. In some cracks, reflective surfaces appeared as if themselves layered. Thin sheets, parallel and precisely spaced. Such regularity in spacing begged hypotheses: periodic sedimentation, layered deposition through punctuated. Speculative frames opened but did not resolve. Documentary reasoning in this mode is cautious about leaping to narrative closure. The presence of regular lines could point to ancient fluid flows shaped by physical laws acting over eons. They could also, with less comfort but still within reason, be the vestiges of structures, the erosion of something once made into the shape of its maker's logic. The team catalogued both possibilities with openness. They filed them as alternative models, assigning likelihoods and Bayesian priors, and then let the data accrue. There was also a temporal sense that swallowed the crew's temporalities. The planet's features suggested processes that took place on the ledger of deep time, cycles of heating and cooling, episodes of fracture and infill, perhaps billions of rotations of a sun the ship had not yet had the opportunity to fully characterize. The human observers found themselves reading a slow biography written in scars. In one sense, everything was legible, physics leaves traces. In another, the legibility teased at gaps. Remnants of processes that had occurred long before human instruments could have witnessed them, now visible, presented the strange spectacle. The mission's ethical dimension grew from these observations. If the anomalies hinted at artifacts or durable arrangements left by processes beyond simple geology, then the ship would be one more presence in a long history of relations with the object. It was a point that reformulated the team's responsibilities. They were not simply gatherers of metrics, they were temporary stewards. The question of interference became urgent. Could a closer pass shear off a reflective facet? Could the ship's exhaust vaporize a volatile that held chemical clues? The team, trained to seek knowledge, now weighed knowledge against preservation. Their choices were small and exacting: adjust approach corridors to limit contamination, avoid high-energy active probing that could heat or ablate surface materials, maintain electromagnetic silence in sensitive bands unless the object itself proved to emit in ways suggesting invitation. That last consideration, whether the object beckoned, remained unresolved. No active beacon had been detected. Periodic modulations in reflectivity could be explained by rotation or by ephemeral shadowing. There were, though, those narrow emission lines in the spectra that hovered at the edge of the known database. Above all, there was the slow realization that any statement about origin carried moral freight. To claim the planetary feature as natural when it was not would be to erase possibility. To claim it as artificial without robust evidence would be to project meaning where method insists one must remain humble. The documentary mind leans toward humility. It prefers to narrate options rather than to close them. In doing so, it teaches a larger lesson that knowledge is not simply accumulation but conversation among instruments, among people, and across time. The planet kept revealing itself in fragments. Each pass delivered new points: a microplume that suggested subsurface reservoir activity, a reflective seam whose polarization signature matched certain high-order crystalline orientations, a shallow gravitational lensing that hinted at an internal mass distribution not uniform with simple accretion models. These fragments aggregated into a problem that was as aesthetic as it was scientific. The planet's face looked like a palimpsest, overwritten multiple times by processes that ranged in their predictability. The ship's instruments, patient. A final, quieter layer was the subjective one, the crew's sense of their place in all this. They were aware, collectively and in the small private ways humans always are, of their tiny duration. They owned the knowledge that their presence would be an instance in a line of witnesses, future missions, automated surveys, whoever would read the data tapes they were preparing for transmission. Their choices in the next hours and days would become the first drafts of an archival voice about this place. It was a responsibility that deepened their procedural care. The approach would continue to be cautious, scientifically rich, and ethically informed. When the ship settled into its holding pattern, the planet continued its quiet work of being inscrutable and eloquent. On screens it rotated, fissures through shadows that shifted with slow, dignified certainty. Plumes rose and vanished like sighs, and reflective patches glowed against a cold background. The team watched as one watches an old manuscript under careful light. Not as conquerors, but as readers, aware that the page had been written by processes older and more indifferent than their arrival. The documentary voice must end this section not with an answer, but with an insistence. Maps can be wrong, databases incomplete, and yet the universe will continue to present places that force human humility. The vessel had found an unlisted world and had chosen, for now, to read it with slow hands and quiet reverence. What would be found in the pages of its surface, whether merely a complex geological argument or the residue of agency long vanished into entropy, remained a suspense. The mission was built to live inside. The approach was not an arrival, but the beginning of an undertaking. What does a dying planet look like when it is seen not as a single image, but as a ledger of processes, an object whose appearance is the record of exhaustion? That question opens this chapter, a question about the visible grammar of decline and about how a series of measurable signs cohere into a story of ending. It is an image that returns to instrument panels and to human minds with equal force, a globe that emits ribbons of red light as if the skin of the world was split and its veins ran incandescent. From the ship's perspective, the first striking fact was not only color but motion. The surface, where it could be resolved, threw up bands and streaks of intense, molten red emission. Not simply isolated lava lakes, but a network of flows that stitched across fractured plate margins. These were not the slow, localized rivers of a volcanically active young world. They were widespread, like glowing sutures along a planet being unstitched. In thermal maps, the red saturated the palettes. Bright cores of infrared energy coexisted with vast regions that registered near absolute zero. This red light came in waves. Long-exposure imaging showed pulses, surges of luminosity that spread outward, then waned, as if the planet belched heat in spasms. Spectrometers recorded emission lines consistent with silicate melt and with incandescent iron and nickel phases. High-resolution spectral slices revealed that some of the red glow was not purely thermal at all. Recombination lines and narrow bands suggested charged particles exciting a thin layer of upper atmosphere as they fist-punched through it. The effect resembled, in the data, a fevered skin, a planet burning its remaining internal energy in irregular. Above those surface flares, the atmosphere itself behaved with an alarming, theatrical complexity. It was thick, dense enough to scatter light and damp thermal contrasts, but not passive. Long baseline imaging showed the gas being swept into enormous vortices, cyclones so large that they would have been continents on Earth. These vortices did not merely whirl, they reorganized atmospheric mass on orbital timescales, drawing moisture and particulates into columns that reached high into the upper layers. Polarimetry and Doppler LiDAR both confirmed organized shear flows, jets folding into one another. The vortices had structure. Some were cold core storms, spinning darkly with suspended particulates, their central pressures so low that the surrounding atmosphere collapsed inward, scraping at the rims of fissures below. Others were warm core, carrying incandescent aerosols lofted from vents that pierced the crust. When those vortices crossed the glowing seams on the ground, they painted the clouds in crimson, turning the sky into moving bands of molten color. The visual effect was not simply dramatic, it was diagnostic. The interactions between surface outgassing and atmospheric circulation told a story of coupling between. Beneath this fevered skin, the geology itself displayed a vocabulary of collapse. High-resolution topography, built from LiDAR and stereo imaging, revealed a landscape of incipient and active subsidence. Plates, where they were recognizable at all, no longer moved with the slow, predictable drift of tectonic convection. Instead, large swaths of crust were shearing, cracking, and then dropping away into gulfs, abrupt vertical displacements that left escarpments hundreds to thousands of meters high. Where continents had met the sea, shorelines had retreated rapidly, leaving cliffs cut sheer into evaporite flats. The instrument suite listened to these failures. Seismometers, distributed via remote penetrators, the ship had judiciously not deployed at first, recorded a cascade of quakes clustered in spatially coherent swarms. Each swarm began with a sharp, high-frequency onset and then devolved into lower-frequency rumble as entire blocks slid and ground against one another, Gravimeters, integrated over days, measured mass redistribution consistent with crustal slabs collapsing into deeper, denser reservoirs. In a number of places, the loss of surface mass created localized negative gravity anomalies. Those voids were not simply empty holes. Where the crust failed, the planet exhaled. Plumes of gas rose from pit mouths, visible in both ultraviolet scatter and in mapped particulate columns. The gases carried sulfurous compounds, water vapor in low abundance, and complex oxidized molecules hinting at the thermochemical reworking of surface organics, where organics existed. The plumes were windows into an interior chemistry that had been forced into contact with space by collapse. In some places, the plumes were accompanied by incandescent spray, droplets of molten material flung up. The hydrological story was, painfully, simple and final. Seas and rivers, where they could be inferred from topographic basins and former drainage patterns, had largely desiccated. What remained were salt flats, polygonal cracking, and entrenched channels choked with sediment. The spectral signatures of argillaceous minerals and evaporites were abundant. Magnesium sulfates, chlorides, and nitrates laid down in the last throes of standing water. Shorelines that once bore terraces now showed lichen-like coats of mineral bloom. Deposits that once formed over seasons now compressed into crystalline signatures that the ship. In certain basins, the imagery hinted at an old intimacy with water. Rounded terraces, deltas preserved as fan-shaped deposits, and fluvial meanders frozen mid-curve suggested an environment that had been dynamic and alive to liquid transport in its recent past. Yet those signs were overprinted by salt-crusted pavements and fissures that split the old beds, as if the world had been drained and then shaken apart. The pace of this last retreat was critical. Time-lapse imaging showed shrinkage over months, channels that drained, ponds that silted, ephemeral pools that flickered and vanished. For observers, the physical evidence suggested multiple potential causes, and here the narration must not leap without rigorous framing. The failure could be internal, heat loss from the mantle leading to reduced convective vigor, collapse of the dynamo, and the consequent erosion of atmospheric shielding, runaway chemical reactions that consumed volatiles, or the exhaustion of a water inventory by sequestration into the mantle. It could also be external. Tidal heating that had episodically stressed the crust until it fractured, bombardment that punctured reservoirs and prompted cascading failure, or stellar variability that altered surface energy balance over long periods. Amid these geological and atmospheric facts, many small, haunting anomalies persisted. In desiccated river valleys and along retreating shorelines, the imaging revealed linearities and repeatable alignments that broke the purely stochastic expectations of sedimentary deposition. Bands of outcrop ran in parallel across tens of kilometers, their spacing too regular to be merely erosional riffles. Reflectivity measurements of some of these bands returned high, coherent values in narrow spectral windows, signatures that, in terrestrial archivistics, could indicate processed surfaces. The documentary framing of such signals demanded restraint. The presence of material signatures that deviated from baseline mineralogy was not evidence of agency, it was a clue. Scientific discipline requires the enumeration of alternative natural mechanisms that could produce similar features. Hydrothermal precipitation producing layered metallic film, impact fusion producing glassy seams, or wind sorting of dense particulates into regular patterns. Yet one must also allow the thought that durable arrangements can survive the death of their makers. That thought carries moral and intellectual weight. How humans choose to speak about this possibility is itself a part of the story. There is a careful grammar to speculation in documentary work. One must be evocative without being credulous, generative without being reckless. In practice, that means cataloguing the facts and then situating them in models. What could produce such reflective bands? How do layered evaporites interact with persistent heat flows? What are the expected lifetimes of manufactured alloys under long-term radiation and impact weathering? The vessel's team, a distributed intelligence merging human judgment and algorithmic rigor, compiled these questions. The emotional texture of this investigation deserves mention. The observers, if the term is used loosely as a human stance, experienced a blend of melancholia and curiosity. There was the academic satisfaction of a data set that refused simplistic interpretation, and there was a deeper, almost ethical sorrow at the sight of a biosphere or a world system reeling into finality. The imagery of dried seas and collapsing continents imposed a humility. Planetary lifespans, in the register of deep time, are vast and indifferent. The human tendency to project continuity is fragile by comparison. Operationally, the mission responded with the same conservational ethic it had practiced earlier. Close passes were calibrated to avoid introducing contamination that could obscure subtle spectral signatures. High-energy probes were deferred in favor of extended passive monitoring. Where the ship had the capacity to deploy small passive reflectors or to place remote inert sensors in range, the team favored measures that would preserve the scene over those that would alter it. Each measurement was accompanied by metadata, time, instrument state, solar phase angle, and the full chain of corrections. The larger context that documentary narration insists upon is not only physical, but temporal. To see a planet in its death throes is to be pushed into thinking about memory at planetary scale. Geological layers are memory. Salt flats are memory. The red flows and the vortices are not just present phenomena, they are the physical sentences by which a world recounts its end. Instruments, then, are translators of a language of decay, and the mission's record is an act of translation for those who will come after. That act carries with it responsibility to precision, to humility, and to the possibility. One of the most sobering aspects of observing planetary death is the irreversibility implicit in many of the signatures. When entire plates fail and basins desiccate, when the atmosphere reorganizes into violently unstable vortices, the system's return to a previous equilibrium becomes ever less likely. Recovery, if possible at all, would require timescales and energies far beyond human intervention. This reality reframes curiosity into a kind of stewardship. The duty is not to rescue, but to remember and to understand. The account closes, as the section must, not with neat closure, but with a sober insistence on attention. A planet in its death throes presents a complex of signs: red, molten flows, dense, convecting atmosphere arranged into monstrous vortices, crustal failure and the rending of continents into chasms, desiccated seas and the salt-caked skeletons of former rivers. Each sign by itself might be passable by models of planetary physics. Together, they compose a portrait of systemic collapse, one that invites multiple causal hypotheses and also admits the. In the end, a world's death is both an end and a text. It is an ending for whatever processes once animated it, and it is a text for those who can read the signatures left behind. The mission's job in this chapter of observation was to be both careful reader and patient scribe, to translate the crimson light, the swollen storms, the ruptured crust, and the dry riverbeds into a narrative that would survive beyond the fragile tenure of any single crew or craft. In that work lay a quiet, profound human aspiration to listen to endings without hastening them. What does it mean to find in the ruin of an entire world the deliberate signature of a mind that no longer speaks? That question, blunt and stubborn, opens the next page of the mission's ledger. It is not an image of a single ruined street or a toppled tower. It is the confrontation with scale, with lines and angles so regular and so vast that they demand explanation beyond random geology. Here, deep time has done its patient, erosive work, and yet something remains that refuses to be explained away by simple chance. The planet's color changed before the forms themselves became legible. From distant transits it had hinted at a cold blue-gray. In closer passes, the palette shifted with unsettling speed, as if someone had turned a vast wheel of paints and revealed a new layer beneath. Where the surface had been muted and slate-like, fissures began to exude a deeper, slow light, washes of deep crimson seeping along fracture lines and pooling within great chasms. This change was not uniform. It happened in waves and patches, a shifting theatre in which cold expanses were intermittently punctuated by molten tongues, incandescent veins that bled through the crust and stained the atmosphere. Those cracks were not small. LiDAR and stereo imagery traced them as fault lines hundreds of kilometers long, some of them tearing across plain and plateau with the brutal geometry of a planet being unzipped. Along their rims, material sloughed into the depths in great sheets. When light caught certain angles, it revealed edges that were unnaturally straight, contours that matched in ways that suggested repetition. A repeated module across a landscape otherwise overwhelmed by stochastic collapse. The combination, the sudden chromatic shift from blue-grey to red, and the emergence of such regularity along gigantic rents. In those rents, half buried and half melted by the creeping heat, the instruments read the silhouettes of geometry. Radar returns carved out shapes that the eye could accept only grudgingly. Arcs and ring-like outlines, rectilinear plans hinting at rooms or courtyards measured in tens of kilometers. Long, ribboned terraces that ran parallel for great distances. Where dust and vapor had washed portions clean, reflective panels appeared. Glossy, glass-like sheets with polarization signatures that suggested alignment at scales inconsistent with random crystalline growth. In other spectral bands, grainy textures alternate. The term structure is slippery. Sedimentary bedding, lava flow fronts, and certain mineral depositions can mimic architecture if one looks with a wish rather than with a skeptical eye. The mission's analytic discipline therefore built a scaffold of tests. Geometry was not, alone, definitive. What mattered was conjunction, the co-occurrence of scale, repeated proportion, material anomalies, and contextual placement within sheltered basins or atop engineered foundations. When multiple independent observables converged, a rectilinear outline corroborated by coherent reflectivity spikes, the traces that suggested past life or past labor were of several kinds. There were linear networks that resembled road systems, running for hundreds of kilometers in near straight lines, sometimes intersecting at nodal points where circular formations clustered like hubs. These nodal formations often sat at the mouths of sheltered basins, as if sited intentionally for resource access or for environmental protection. In other regions, terraces stepped down with regular heights, too uniform to be explained by simple erosional terraces. Instead, they behaved like engineered platforms. Elsewhere, fields of regular material signatures deepened the enigma. Spectral analysis detected narrow bands incompatible with the local regolith's baseline chemistry. Some bright patches displayed complex composite spectra, signatures of silicates melded with narrow anomalous features suggestive of alloying, of surface treatments that could reduce oxidation or disperse thermal radiance. There were traces of glassy vitrification that extended beyond impact, melt zones. Sheets of fused material that curved and overlapped, their surface textures consistent with cooling from high-temperature flows, but organized in ways that hinted at casting or laying rather than mere accidental. Scale pushed the mind toward imaginaries that were difficult to hold. These were not ruins of human scale. They were infrastructural scars of planetary proportion. A ring tens or hundreds of kilometers across might be the collapsed remnant of a transport artery, a power girdle, or a regulatory lattice designed to modulate climate on a global scale. Columns of aligned cavities could be part of a distribution network, their arranged regularity serving a function lost to erosion. Alternately, on the plainest explanatory level, the features might be natural, columnar jointing on an unimaginable scale, rhythmic depositional pulses or preservation biases mattered. Not everything survived deep time equally. Organic matter, ephemeral constructions, and unfired materials vanish rapidly on geological timescales. Durable materials persist. Metals corrode, but they often leave behind telltale residues, oxidation fronts, secondary mineral growths, subtle magnetic anomalies. Ceramics, glass, and certain polymers, when shielded from radiation by overburden or by burial in anoxic deposits, can endure for astonishingly long epochs. The planet's tectonic and erosional regime, as reconstructed from stratigraphy, suggested intervals of burial alternating with this interplay. Destruction revealing preservation was visible in a dozen small haunting ways. In a basin where evaporite flats now baked in crystalline lattices, the imaging revealed the faint outline of superimposed grids beneath salt crusts. In sheltered gullies, glassy beads clung to overhanging ledges, their shapes too uniform for random tektite formation. Their surfaces bore microstriation patterns consistent with abrasion along fixed trajectories. Subsurface radar profiled cavities that aligned with surface geometry, forming an integrated. The color transformation of the planet, the sudden reddening of areas, and the atmospheric flush carried its own testimony. Red is not merely sensation, it can be chemistry. Oxidation of iron-rich minerals, combustion of organics, or the release of specific aerosols can shift a planet's sky and surface toward crimson tones. In this case, spectral data indicated a confluence of processes: thermochemical oxidation, where molten flows exposed reactive minerals, the uplift of iron-rich particulates into the atmosphere, and the generation of charged particles that excited upper atmosphere. The possible functions of the revealed structures were difficult to ascribe with confidence, yet imagination, disciplined and skeptical, could propose reasonable classes. Some features read like transport scars, long linear conduits designed to move mass or energy across the surface. Others resembled containment shells, broad, shallow basins with reinforced rims and inner partitions, as if intended to hold volumes of liquid or volatile substances. Certain ringed complexes, concentric and precise, suggested ceremonial or regulatory designs, perhaps orbiting radiative elements or acting as focal collectors for energy. The disposition interpretation required method as much as mind. The mission adopted a layered approach: morphological classification followed by material corroboration and then by systemic context. Each suspected artificiality had to be tested against natural analogues. Would a flow-borne tweak produce the same rectilinear outline? Could periodic sedimentation mimic the spacing of aligned pits? Would the magnetics produced by a buried metallic core also appear if the formation were a hydrothermal precipitate? Each test moved the hypothesis marginally to. Alongside analytic rigor, another register grew louder: the ethical weight of encounter. The possibility that these were the last monuments of a former intelligence instilled a conservational imperative. Any disturbance could erase the fragile clues embedded in surface chemistry, isotopic ratios, or nanoscale striations preserved on long-sheltered surfaces. Instruments, as observers, became guardians. Choices about passive versus active probing, the emission of radio or particle beams, even the proximity of low-thrust passes, all acquired moral valence. This realization shifted the tone from curiosity to a kind of reverence. The documentation of ruins is not a neutral act, it is an act of memory. To record is to claim witnesshood, and to claim witnesshood is to accept responsibility. The mission's protocols, originally designed to minimize contamination and to maximize scientific return, accrued an extra clause: do not convert curiosity into desecration. The instruments were configured to be as non-invasive as possible, to favor passive observation and multi-angle triangulation over drilling or displacement, at least until the weight of evidence justified a Philosophically, the encounter with ruins reframes human notions of continuity and legacy. Civilizations in speculative thought are brief flickers on geological calendars. The objects most likely to outlast speech and memory are the durable, the redundant, and the scattered, things that can survive burial, radiation, and impact. To find such objects is to read an epitaph written in metal and stone, and to feel acutely the limits of comprehension. Practical questions dovetailed with existential ones. Did those who built these things intend to be remembered? Were these structures functional, symbolic, or both? Ambiguity persisted as the central motif. Evidence compiled into a compelling portrait, but never a closed case. The mission's reports catalogued items of interest with careful language, structural analogues observed, material anomalies requiring further corroboration, morphologies consistent with non-random arrangement. This lexical conservatism did not dampen the resonance of the images. On screens, the ruined arcs and the patterned terraces read like pages from a book whose ink time had faded, but whose sentences were still legible enough to suggest narrative. For those who would later read the tapes sent back to distant archives, the images and spectra would be a provocation. They would be invitations to reconstruct not only events but intentions. Documentary narration, the voice that stitches observation into meaning, must hold two attitudes simultaneously: rigorous skepticism and imaginative generosity. It must be willing to honor the possibility that the universe occasionally preserves the evidence of the ephemeral, and to do so without leaping to fantastical conclusions. The final image of this chapter is quiet and unassuming but charged with consequence. Across a salt-streaked plain, a ringed formation, half filled with crystalline deposits and half exposed by a recent fissure, casts a long shadow. Its arc is imperfect, a palimpsest of natural and possible artificial processes, but its geometry and materiality refuse to be neatly filed away. In the calm that follows a day of data gathering, the mission's archive grows thicker: higher resolution frames, polarization maps, gravimetric cross-sections, and layered spectral profiles. Each file is a small promise to future readers, encountering the traces of former life. Infrastructural, cultural, or biological, on a dying planet is a particular kind of sorrow. It is not the sentimental grief for the vanished, it is the practical grief of recognition. One records because the record may be the only bridge between the silence that remains and the questions that future minds will ask. The mission's instruments continued, in their patient, unblinking way, to read the ruins and to leave notes, a catalogue of regularities, a ledger of anomalies, a set of modest hypotheses. The planet, its color shifting from slate to crimson beneath the slow. What does a world sound like when its heart begins to fail? That is the image that opens this chapter, not a single catastrophe, but a slow, escalating grammar of collapse, written in frequencies and heat. The ship's instruments, patient and precise, translated those frequencies into a story no single photograph could tell. A story that offered, with unnerving clarity, a plausible cause for the ruinous geometry and the molten convulsions already observed. The data pointed consistently toward one explanation: the planetary. This hypothesis arrived not as a single smoking gun, but as a conjunction of complementary signals. Seismometry, long integrations of low-frequency, planet-spanning oscillations, revealed modes of vibration that were inconsistent with localized tectonics. Instead of isolated swarms or restricted rupture zones, the seismic signatures recorded by remote passive sensors showed coherent, global-scale oscillations. The frequency spectrum was loaded toward very low frequency, long-period energy, tremors that implied whole-planet modes, as if the body were ringing like a bell struck deep beneath the crust. These were not the sharp, impulsive spikes associated with surface. Thermal imagery corroborated this interpretation. Infrared mapping showed anomalous heat flux concentrated not only along the great fissures and volcanoes already visible, but also emerging from unexpected linear belts inland, intersecting regions of apparent structural complexity. The heat signatures were temporally correlated with seismic pulses. A quake cluster would be followed hours later by a broadening thermal halo and then by plumes of gas and particulate projected into the upper atmosphere. Those plumes carried high-temperature species and chemical fingerprints associated with deep mantle and core mantle boundary processes. Gravimetric readings painted the third stroke. Long baseline gravimetry, accumulated over weeks of integration, revealed migrating mass anomalies. They were not the static lumps of dense ore or localized subterranean chambers. They were moving gradients, rising and subsiding in patterns that suggested internal reorganization, blobs of buoyant mantle material ascending, denser pockets sinking, the convective engine shifting its patterning. In some sectors, Gravimeters detected sudden localized decreases in shallow gravity, consistent with rapid mass loss from crustal collapse into deep. Perhaps most telling was the behavior of the magnetic field. Magnetometry returned a disturbing record: long-term weakening, intermittent polarity excursions, and localized magnetic anomalies that flared during the seismic thermal events. The field's coherence had been compromised, whether by a slowdown and chaos in the dynamo that once maintained a stable dipole, or by abrupt changes at the core mantle boundary. The magnetosphere's failure exposed the upper layers to intensified particle flux and to the slow attrition of atmospheric integrity. The planet's shielding, once dependable, had become a sieve in places. Taken together, these signatures formed a plausible causal chain. The core's destabilization, whether from gradual secular evolution or from a sudden internal phase change, had reorganized convective patterns. That reorganization delivered heat and mechanical stresses unevenly to the lower mantle, producing mantle plumes, lithospheric doming, and catastrophic failure along pre-existing weaknesses. The crust, long under the tensile stresses of plate rearrangement, responded with massive shearing, subsidence into newly opened rifts, and widespread volcanism. The volcanism, in turn, this scientific reading requires nuance. Core destabilization is not a single, monolithic event with one cause. It is a family of processes, each with distinct signatures and timescales. The mission's analysts outlined several plausible mechanisms, none of which could yet be singled out as definitive. One line of reasoning favored internal evolutionary processes. Large terrestrial bodies undergo long-term cooling, inner core crystallization, and compositional differentiation. As an inner core grows, it extracts heat and light elements, changing buoyancy forces at the core mantle boundary. If the compositional stratification becomes unfavorable, iron snow, solid iron crystals precipitating within the outer core can alter convection patterns catastrophically. Such stratification can temporarily halt the dynamo, trigger localized convection reversals, or produce. Another hypothesis emphasized mantle dynamics. Mantle overturn, the sudden rearrangement when dense accumulated lithosphere founders into the deep mantle, can provoke bursts of upwelling from the core mantle interface. That act can be violent. Whole slabs plunge, displacing material and forcing hot, chemically distinct blobs upward. The collision of upwellings with the lithosphere produces the observed linear arrays of fissures and the synchronous burst of surface heat. The gravimetric migrations and the patterns of plume activity supported this. External triggers could not be dismissed. A large impact, even one from which the planet partially survived, could seed long-term instability, shock heating of the deep mantle, perturbation of the rotation state, and the injection of angular momentum that fosters tidal stresses. Of particular interest were orbital histories reconstructed from precise orbital tracking. The planet's orbital elements suggested periods of increased eccentricity in its recent past, a condition that could have induced tidal heating via resonance with a companion or a belt of massive bodies. Tidal flexing, if sustained, can produce internal heat sufficient to destroy. There were also hybrid models. For instance, a long-term secular cooling might make the interior marginally stable, and a later event, an impact, a tidal surge, or even the stochastic crystallization of an inner core layer, could tip the system into a new dynamic state. The planet's response would then be rapid and global. The seismic modes, the thermal pulses, the plumes, and the atmosphere's reaction would all be manifestations of a single bifurcation in planetary behavior. The mission's job, as it collected data, was to find the fingerprints that distinguished these scenarios. Those plumes, in particular, were invaluable because they acted as the planet's courier. Remote spectrometry of the volcanic emissions provided proxies for depth by virtue of their isotopic and chemical composition. Elevated helium-3 to helium-4 ratios would indicate primordial deep sources. Anomalous sulfur isotope fractionation could signal high-temperature reduction of crustal materials. The mission's mass spectrometers, tuned for high-velocity sampling of dispersed plumes, found exactly these markers. In many of the major eruptions, gas compositions were heavier laden, with deep source signatures. Seismology provided an additional timestamp. The low-frequency global modes and the episodic burst patterns suggested an escalation rather than a single instantaneous collapse. Weeks of low-level tremor preceded larger pulses, a crescendo similar to the increasing frequency of microquakes prior to a major rupture on Earth. That pattern was essential to reconstruct the timeline, a preparatory phase of slowly reorganizing convective cells, followed by episodic, increasingly energetic upwellings that culminated in the surface expression of cataclysm. The periodicity also raised a terrifying implication. What did this mean for the possible intelligent builders whose traces the mission had mapped? The narrative that links core destabilization to societal ruin is tragically straightforward. Engineered systems, energy grids, waterworks depend on environmental predictability. A planet whose crust heaves unpredictably, whose seas desiccate and then are scoured by acid-laden plumes, and whose magnetic shield fails, will see its most complex systems fail first. Massive, synchronous earthquakes can sever distribution networks and collapse buried archives, planetary cities under meters of Teflon glass, vitrifying. Yet the documentary stance resists narrative shortcuts. Correlation is not causation, and the mission's reports threaded each causal claim with caution. Alternative natural explanations were catalogued alongside the typology of collapse. Statistical priors were assigned, null models were tested. Each new plume sample, each refined seismic tomograph, nudged the balance toward or away from specific mechanisms. The team, that hybrid of human judgment and algorithmic modeling, practiced a conservative epistemology, to admit what the data supported and to acknowledge the liminal space where uncertainty. There were also ethical dimensions to the science itself. The suspicion that the planet's interior was active and that the world continued to cough up deep material shaped the way observations were conducted. The mission's mandate to minimize interference acquired a new urgency. Any active probing, high-energy impingement, aggressive, deep-penetrating radar blasts, or even the deployment of heavy probes risked triggering additional instability. The principle became one of restraint, to observe in passive bands, to await the planet's own emissive acts, and to collect what the world chose to give rather than to provoke fresh upheaval. Ultimately, the hypothesized instability of the core reframes the wreckage the ship had seen. Geometry and reflectivity, terraces and linear alignments, vitrified plains and salt-choked basins, these are not merely archaeological curiosities. They are the consequences and archives of a planetary-scale physiological crisis. The planet's final acts of violence and creation were both destructive and preservative. Molten flows that incinerated some traces also sealed others in glass. Ashfalls that buried infrastructure also entombed delicate microstratigraphy. The mission's recordings thus became an act of triage, and the chapter closes on a sober register. A planet's heart can fail for many reasons, and the signals registered by instruments offer competing narratives that must be read together. The data gathered so far tilt toward a profound and consequential conclusion that interior dynamics, a failing dynamo, a mantle overturn, or an externally nudged convective reconfiguration, triggered the systemic collapse now visible on the surface. That conclusion explains both the synchrony of catastrophic events and the specific material uplift observed in volcanic plumes. It explains how infrastructure could be both vitrified and dispersed, how, in the deep silence that follows the elaboration of a plausible cause, the human affective tenor of the mission finds voice in a collective mood, a mixture of grim comprehension and reverent duty. The planet's dying heart had shaped the fate of whatever had lived there. The ship's role, for now, is to be a recorder at the bedside, to listen, to log, and to resist the urge to intervene recklessly. The archive being generated is not merely scientific data, it is testimony. It will help future narrators reconstruct not just how the planet died, but how its remnants came to lie where they were found. In those records, perhaps, What does it mean to find, in the thin dark above a dying world, the scattered bones of a technology that once trusted the sky? That question, image, hypothesis, and provocation all at once, opened a new chapter in the mission's ledger. Orbital space is the natural archive of a planet's late-stage projects, the place where ambitions to move mass, to harness energy, or to reach beyond gravity take their final neglected form. To discover deliberate metal in orbit is to find a memory suspended, spinning slowly, where time and vacuum conspire. The first hint arrived not as a photograph, but as a whisper on radar. A pulse returned with an unexpected coherence, a cluster of reflections, each with the crisp, high-contrast return characteristic of metal rather than rock. On long-range displays, the returns arranged themselves into a pattern, points that traced out regular arcs and loops rather than the random scatter expected from debris thrown aloft by impacts. The radar signature was precise, narrow band reflections with polarization shifts that suggested flat, planar surfaces and thin edges. In the calculus of the ship's instruments, the signal, remote sensing, then layered itself into a slow, methodical interrogation. LiDAR mapped the fragments' silhouettes, painting them as sparse lattices and sheet-like structures caught in trajectories that hugged the planet in a range of inclinations. Optical images, over long exposures, captured the glint of specular reflections, flashes that occurred at predictable altitudes and phase angles, consistent with rotating panels or facets. Passive infrared detected faint thermal variations on some larger pieces, sun-warmed surfaces contrasted against shadowed backs, the signature of objects that still obeyed the day-night of their host planet. Taken together, the data suggested that these were not merely random chunks of metal. They presented as artifacts with geometry, plate-like sails, tubular nodes, ringed frameworks, and at least one roughly cylindrical mass that cast a consistent radar shadow like the remnant of a habitable module or storage tank. Scattered among them were smaller fragments, shards, perforated panels, and pieces whose edge radii and uniform thickness betrayed manufacture. Micrometeoroid pitting and subtle mottling indicated prolonged exposure, but the pattern of wear did not erase the traces of human-like engineering logic. The orbital distribution was as telling as the materials. Rather than a spherical shell of random velocity vectors, the fragments clustered into several preferred planes. One belt traced an inclination aligned with the planet's equator. Another sat in a high-inclination orbit that intersected the polar regions. Where fragments approached nodal intersections, their density increased. Such clustering bore the signature of deliberate deployment, constellations, rings, platforms, or orbital arrays placed with intent for coverage, communication, or energy collection. Impact ejector, in contrast, tends to produce a more, but organized does not mean recent. The ship's instruments had other clocks. Surface weathering of the fragments and micrometeoroid impact rates allowed estimation of exposure, ages, subtle oxidation signatures, a thin patina on exposed surfaces, the presence of secondary minerals grown in microshadowed crevices, suggested timescales of at least millions of rotations under the planet's radiation environment. Power sources were absent or deeply attenuated, no broad-spectrum thermal anomalies indicated active reactors, and no persistent radio emissions rose above the background hiss. A handful of two explanatory arcs rose to the top of scientific discourse. One was internal and human-like in its narrative. These fragments were the remnants of a native orbital infrastructure, satellites, power collectors, orbital factories, or a ring of platforms intended to redistribute energy, abandoned or left in place when surface conditions deteriorated. The other was catastrophic. The objects had been lofted into orbit by a violent event, a planetary-scale energy experiment gone awry, or the impact of an external body, and subsequently fragmented into the field observed. The evidence, if the indigenous infrastructure hypothesis held, that had profound implications for historical interpretation. An orbital constellation implies a degree of engineering sophistication and ongoing logistical capacity, launch systems, orbital maintenance, and likely a feedback between surface industry and space-borne platforms. The configuration of fragments could then be read as the last act of a planetary-scale program, perhaps a network meant to gather and transmit energy, to facilitate climate control, or to serve as a communication scaffold. Such programs, if they existed, would have been vulnerable to the very planet. A planetary-scale energetic planet, an engifor autonomous scale energetic challenge, injectors, scalacteristic footprint, the deployment of beacons, collectors, and conductive tethers, and in Clalea, the scattering of high-energy remnants. Alternatively, an asteroid orbits and energy remnants. Alternatively, an asteroid orbits and is space shredding platforms and flinging them into orbital paths. If a collision had occurred, its signature might be discernible in the eccentricities and inclinations. Impact ejector often bears an energy gradient. Faster, smaller fragments reaching. Material diagnostics became crucial. Spectrometers found alloy compositions that were not purely meteoritic. The reflectance curves and narrowband absorption features pointed to engineered alloys doped with light elements. Boron, carbon composites, and refractory alloys designed for high thermal tolerance. Certain surface treatments designed to mitigate radiation, thin films with exotic dielectric properties, were present, their spectral fingerprints distinct from natural mineralogy. Moreover, residues of lubricants, polymer binders, and complex organic stabilizers suggested processes. The fragments also told a story of age in micro-detail. Microfracture patterns, examined through high-resolution radar interferometry and polarization mapping, suggested cyclical thermal expansion had been at work for a very long time. Pitting consistent with micrometeor impacts, borostratigraphy. The outermost layers showed a higher density of microcraters gradually giving way to interior surfaces with fewer marks, a record of slow exposure punctuated by episodic cleaning events. Those cleaning events could have been atmospheric drag in denser epochs or thermal stripping during major outgassing. There were, however, skeptical counterweights to every inference. Natural processes can concentrate iron-nickel meteorites in orbital light distributions around the small body due to complex gravitational interactions. Electrostatic lofting of regolith, followed by collisional coagulation in low gravity, can sometimes produce sheet-like aggregates that reflect light in unusual ways. The mission's analysts therefore ran multiple null models, asking what combinations of natural phenomena might reproduce the radar and spectral data. Some models could approximate aspects of the observations, but struggled with certain regularities. Operational and ethical considerations soon shaped the mission's tactical posture. Orbital debris, particularly objects containing volatile compounds or energetic residues, can pose risks to any approaching craft. A conservative doctrine was adopted: passive observation first, active approaches only where the science would be irretrievably improved and the risk to the mission's craft or to the integrity of the orbiting archive was acceptably low. Remote deployment of inert marker buoys and long-range interferometry were preferred over physical sampling. When the mission did dispatch small, untethered microprobes to skim the fragments' wakes at safe standoffs, that fidelity extended into questions of provenance. If these were artifacts of a former civilization, then their preservation becomes an act of cultural stewardship, not merely scientific exploitation. The mission's protocols evolved accordingly. High-resolution mapping, multispectral cataloging, and redundant archiving of every measurement became the equivalent of careful photography and transcription by archivists of the cosmos. The possibility that the orbit held monuments, functional or symbolic, imposed a moral dimension on what could otherwise have been a pure technical exercise. A decision to disturb an object for the sake of science. The fragments also reframed the narrative of the planet's demise. Orbital artifacts are durable records. They are the last outposts of a civilization's reach. If these were native constructs, they stood as testimony that a civilization had once extended its agency upward, seeking to manipulate energy, to communicate across distance, or to escape a failing surface. If their presence owed to an accidental lofting via impact or an experiment, They testified to the scale of human-like ambition, experiments and collisions that move planetary masses into. The emotional tone of that realization hovered between melancholy and a kind of solemn awe. The orbiting fragments made the loss concrete in a way molten seas or riven continents could not, an archaeology of the sky. To look at them was to imagine hands that had designed panels to catch light, to build machines that spun in precise attitude, and to launch hardware into tight frames that now, abandoned, traced slow, patient arcs. The images that the ship recorded, sequences of glints and slow rotations set against the black, read like a slow-motion elegy. Yet the mission resisted elegy in favor of documentation. It catalogued each fragment, assigned provisional identifiers, and cross-referenced orbital elements with surface features below. In several cases, spatial correlations emerged. Clusters of fragments orbited above areas where the ship had earlier detected rectilinear terraces and vitrified seams. Such alignments strengthened the case that surface and orbital architectures had once been part of an integrated system. Where rings intersected former basins, the fragments' orbital nodes corresponded to presumed hubs on the ground, suggesting launch, servicing. Finally, there was the long view. Orbital artifacts persist in a regime that's peculiarly resistant to many of the erasures of time. Radiation, micrometeor wear, and the slow tick of solar radiation pressure will alter appearance, but in vacuum, many forms endure. What the mission was tracing, therefore, was both transient and enduring, the final breath of activity in the planet's industrial atmosphere, captured in forms that would remain for millions of years. The observers saw themselves as custodians of that record, not only measuring physics, but preserving a cultural testament that might. The discovery of these metallic fragments in orbit reframed the mission's work. It was no longer simply a study of geological collapse and atmospheric dynamics, it was an inquiry into agency at planetary scale. Whether the fragments were the relics of orbital stations, the detritus of a failed project to harness planetary power, or the scattered remains of a collision that had mixed the natural with the manufactured, they were an argument against oblivion. In the cold silence above a world receding into its final acts, something had been left drifting that remembered movement, design, and purpose. The mission. Some still emitted weak signals, but they could not be decoded. The sentence sat in the mission log like a small, insistent ache, fragments of patterned emission that hinted at language or at systems, but that refused the human ear. For days, the faint pulses had been a background hum in the instrument suite, amplitudes too low for confidence, modulations that mapped onto no known protocol, cadences that suggested repetition rather than noise. They were ghosts on the wire, enough to provoke questions and not enough to answer them. And then the world announced itself. What followed was a single, enormous event that broke the patient tempo of observation into two eras, before the flash and after. The ship's optics recorded a light so intense it temporarily saturated even the hardened photonics designed for stellar flare protection. It was a white so white that near-infrared and ultraviolet channels both registered distinct spectral signatures, as if the phenomenon were not a simple thermal blaze, but a complex blend of incandescent matter and high-energy plasma. In the imaging sequences, the flash began as a point, and then, over a handful of frames, the instruments spoke back in their own languages. Photometers clipped, their preamplifiers protecting sensors by triggering automatic attenuators. Wideband spectrometers, primed for faint emissions, were suddenly inundated with flux, emission lines that answered like a chorus, overlapping and shifting, some consistent with vaporized silicates, others with metallic vapors driven into excited electronic states. Particle detectors recorded an avalanche, a prompt burst of charged particles, heavy ion signatures unusual for a planetary outgassing, followed by a slower entrainment of more commonplace species, salt. The ship did what any carefully calibrated instrument would do when confronted with an event at a scale beyond its original design. It protected itself, and it recorded everything. Protective shutters and attenuators engaged, data buffers overflowed and were vectored into priority streams, redundant arrays spun up to take over as the primary sensors grit their teeth and soldiered on. Thrusters whispered corrective impulses as the first mechanical perturbations reached the craft. It was an instinctual choreography of hardware, reaction wheels taking up torque, control moment, gyros shifting orientation, attitude control system. The shock, when it arrived, had many manners of arrival. In a vacuum, a traditional pressure wave cannot traverse, yet this planet wore an atmosphere thick enough to carry a real, physical compression outward from the site of the explosion. That compression rolled through the air like a hand across fabric, a bright front followed by an eddying wake. At high altitudes where the ship orbited, the expanding plume entrained atmospheric mass and accelerated it to high velocity. The resulting momentum exchange produced a measurable impulse. Tiny, but measurable. Simultaneously, a cloud of ejecta, molten droplets, ionized metals, and glassy spherules was launched into circumplanetary space. Some of it fell back to the surface in incandescent showers, some of it achieved ballistic orbits, intersecting bands of pre-existing debris. Radar returns grew noisy as the scattering cross-section of the near-space environment increased dramatically. Long-tracked fragments altered their nodes and semi-major axes, nudged by the collective push of the blow. Orbital elements that had been stable, predictably slow to change, now jittered in ways that required immediate recalculation. There was an emotional contour to these technical facts, even when no single human voice narrated them. The bridge, understood as the place in which a small constellation of human minds and machine processes converged, experienced a communal flux that was both physiological and cognitive. The initial surge of surprise gave way to a cluster of feelings that are hard to separate: awe at magnitude, a kind of mourning for whatever had been lost or transformed, and a sharp, practical anxiety over the viability of the mission's instruments. The record of those sensations exists, not in quotes but as patterns in the logs, manual overrides. In the minutes and hours after the detonation, the planet's visage altered in ways that instruments could measure and minds could interpret. Where the light had seared, a new caldera of brightness emerged, surrounded by a corona of incandescent vapor and particulate. Tall plumes rose in successive waves, each wedge of material carrying a slightly different chemical signature that hinted at stratified reservoirs, sulfides first, then silicate melts, then deeper, heavier metallic species. A secondary ring of smaller explosions traced the edges of major fault lines. Mechanical energy had been released along old seas. Perhaps the most disquieting aspect, for those tracking the weak transmissions that had moaned through the background for days, was their response to the event. Several of those faint emitters modulated their intensity in loose synchrony with the explosion. Where before the pulses had been soldierly and inscrutable, now they swelled into momentary clarity. Not clarity enough to decode, but enough to suggest a causal relationship. The amplitude of certain narrow-band signals increased dramatically at the instant of the flash, and then, as the ejecta cloud grew opaque, diminished again, swallowed by the veil of material. The pattern raised a spate of hyper. The analytic machinery of the mission responded with layered care. High-resolution spectrographs were tasked to watch the plume's evolving chemistry. Long integration LiDAR sweeps search for changes in surface morphology. Passive seismic listening aimed to capture the low-frequency planetary ringing that followed major subterranean disturbances. The archive modes shifted into a triage posture. Capture the ephemeral first, fill in the contextual record second, and only then, with a cautious deliberation, consider any invasive probing. That posture was not merely technical conservatism. It was ethical. Once there were immediate, practical consequences to the explosion for the very artifacts the mission had come to study. Orbital fragments that had once traced placid orbits now experienced sudden collisional shuffles. Some of the smaller panels, tethers, and gauntlets were pushed into decay trajectories that promised atmospheric re-entry on timescales shorter than pre-event models had allowed. Debris streams intersected older rings, creating wakes of newly liberated shrapnel that would confound future reconnaissance. On the surface, the rupture had turned sheltered hollows into open records, but also into zones of destructive abrasion, where glassy beads fell. They sometimes fused. These processes forced the mission's priorities into painful arithmetic. Preservation versus interrogation, which should have precedence when both cannot be maximized. The documentary voice of the mission, the set of choices that would filter into reports, bequests, and archives, trended toward preservation. The reasoning was simple and principled. The explosion was a stochastic, irreversible event. The planet had just rewritten portions of its own archive in a way human action could not reverse. The immediate goal, therefore, was to capture that rewriting in as much fidelity as possible. Philosophically, the event complicated the narrative in ways that the documentary mind had to hold with care. There was the temptation to read the explosion, an intentional signal amplified into a planetary-scale flare, a deliberately triggered burn that intended to a planetary scale, flare, a deliberately triggered burn that intended to erase or to announce. The available data, because they offer personality to geological actors, yet the empirical mind demanded alternatives. The release could be a natural blowout of pressurized volatiles, an exothermic chemical reaction in buried strata. The catastrophic in the human register, the explosion sharpened a sense of contingency and urgency. The artifact fields, the orbital fragments, the vitrified seams now took on a new tone. They were not merely relics of a past agency to be interrogated at leisure. They were evidence under active reworking by natural forces. Material that might have survived for millions of years could now be lost in months. The crew's deliberations, recorded in the logs as methodical committee notes rather than as theatrical exchanges, reflected a striking humility. Witnessing the planet's capacity to change at human-relevant timescales imparted. There were also practical windows opened by the event. The explosion, violent as it was, acted as an unintentional probe into the planet's interior. Material ejected from the depths now rode the plume where spectrometers could sample compounds that would otherwise remain sequestered. Noble gas isotopic ratios from the plume gave clues about mantle sources. High-temperature condensates revealed the presence and proportion of refractory metals, and the velocity distribution of ejecta constrained models of subsurface pressure gradients. In this grim calculus, catastrophe had rendered the otherwise inaccessible briefly legible. The mission's policy, yet knowledge arrived with grief. The weak signals that had once been an enigma were now, more than ever, at risk of being explained away as transient excitations. To record an act as possibly intentional, and then to see that act reduced to a physical byproduct, is to live in the tension between narrative desire and scientific restraint. The mission's public-facing files would carry both. The raw spectrographs and time series, the model runs that assigned probabilities to natural versus intentional origins, and the careful, non-committal prose that allowed future analysts to pick up the trail. As hours turned into days, the ship remained a witness too stubborn to leave. It held station at a respectful distance, rotating its arrays to maintain long baseline triangulation even as it monitored shifting orbital debris. The aftershocks, seismic whisperings recorded remotely, small luminous flashes in the newly altered surface regions, the occasional transient radio pulse from within the dispersing cloud, continued to place the world in a state of dynamic flux. Each event, however small, became precious data, each pulse a note in a fugue composed. The explosion reframed everything the mission had believed about temporality. A world that had been read as dying over long eons had, in one moment, undergone a theatre of change that compressed millennia into days. It forced the observers, and the distant audiences who would eventually receive their tapes, to confront an uncomfortable truth that deep time is not always gradual. It can produce avalanches. It can deliver sudden punctuation marks that erase, reveal, and reconfigure the strata by which history might be read. In the telling that would accompany the data, The narrator's voice adopted both clarity and softness. The flash was tremendous but not unknowable. It provided avenues of understanding while also increasing the mystery. The weak signals that had whispered for days now seemed either to have been answers called into being by the explosion or the mechanical groans of stressed materials suddenly energized. Either reading held consequences for how the mission would proceed. The decision to wait, to observe, archive, and resist intrusive action was chosen not out of cowardice, but out of an awareness that in the wake of cataclysm, the duty is. The final image of the episode is not cinematic. There was no dramatic landing or triumphant retrieval. Instead, there was a long, patient sequence of measurements, spectral sweeps of a cooling plume, radar tracks of fragments settling into altered orbits, gravimetric readings recalibrating for redistributed mass, and a dense, prioritized pipeline of archived files zipped and encrypted for transmission to distant repositories. The planet continued to breathe shallowly, its outer skin convulsing in the aftershock. The ship in that vigil lay the central lesson of the moment. To witness a world mid-collapse is to be both a scientist and a mourner. The mission's instruments recorded, the analysts passed, and the archive grew heavy with photons and particle counts, a weight measured not merely in data size but in moral consequence. The explosion had turned speculation into urgency. What had been a puzzle now demanded preservation. The observers understood that their recordings might become the only testimony left when the planet's surface had been reworked beyond recognition. They understood, too, that some signals, faint and undecoded before the flash, might not. And so the ship stayed, and so the logs kept their meticulous, emotion-laced restraint. The world had spoken in a sudden, terrible voice. The mission answered in the only way left to it, by listening, by cataloguing, and by refusing haste. In deep time, a moment like this is a tiny comma. In the human ledger, it is an entire paragraph of history. The recorder did not insist upon explanation. It recorded, and in choosing what to save, acknowledged the frailty of knowing and the gravity of being a witness to endings. What does one do when the thing one has come to read begins to unwrite itself? When the archive is not a library of pages, but a planet, and the pages are flaking away in real time? That question sat at the center of the mission's ledger as sensor streams moved from curious pattern to urgent alarm. Telemetry converged on an inescapable estimate. The system that had been crumbling for millennia would, in the reckoning of multiple instruments, be largely unrecognizable within hours, or, at most, a few days. The data that produced this estimate were not a single dramatic trace, but a chorus of escalating signatures. Seismic modes that had been long-period and intermittent hardened into a crescendo. Low-frequency oscillations increased in amplitude and cadence until the planet's global hum was no longer the slow ringing of a distant bell, but the deep pounding of an organ failing. Thermal maps, once revealing isolated surges, now showed heat fronts racing across latitudes, propagating along fault networks with a speed that betrayed pressurized release rather than leisurely diffusion. Gravimeters, integrating over shifting baselines, registered mass transports. That technical fact produced an ethical and operational problem in the same instant. The mission's mandate was archival, to collect the most complete, highest fidelity record possible of an extraordinary world. But archival impulses demand time, slow sweeps, repeated baselines, redundancy. The planet, by contrast, was now offering data in a single, collapsing window. Some signatures were ephemeral by their nature, short-lived isotopic ratios in freshly vaporized material, charged states of molecules that recombined in minutes, weak electromagnetic modulations that would be drowned by the next. Protocols existed for high-risk encounters, but they assumed a deliberative cadence that the planetary timeline now refused. Central Command, at light hours away, could only be informed. It could not authorize. The mission's responsibility statutes delegated final action to an on-site authority, a distributed decision system combining pre-authorized rules, automated risk models, and human judgment working in collective, anonymized panels. Interpretation of the rules in the face of live catastrophe is not drama, but engineering, threshold graphs, confidence intervals, and decision trees that terminate in either engage or the instruments themselves became narrators. LiDAR point clouds jittered as the planet's surface convulsed. Frame-to-frame registration required adaptive algorithms to keep pace with the shifting terrain. Radar cross-sections that had once produced stable faceted returns now splintered as transient echoes from ejecta swarmed the near space. High-resolution spectrometers reported fleeting, high-energy emission lines, complex organics and refractory metal vapors that faded within minutes as recombination and condensation proceeded. Particle detectors recorded a rising background of microglass and metallic spherules crossing vehicle and aggressive approaches of staff-approach Wiener's sampler packages. Untethered microprobes designed to skim plumes, capture volatile fractions at high relative velocity, and return heralded bursts of compressed data via line-of-sight relay. The price of such proximity was high. The Prosser Pass could also support targeted downlink imaging of exposed interiors. The freshly writ strata, vitrified seams, and ordered terraces that might still preserve traces of agency. The price of such proximity was high. The ship's thermal and shielding budget would be stressed. Navigational margin. The debate that filled the logbooks was less theatrical than the press corps would later imagine. It was a set of layered assessments, Monte Carlo runs that traded sample yield against survival probability, model ensembles that estimated plume lifetimes under varying atmospheric densities, and heritage data comparisons that cross-checked the unique signals against known geochemical decay. Timescales. Where models disagreed, the mission's ethic leaned toward conservatism. Where they converged, action was authorized. Two vectors became critical in pushing the decision one way or another. The first was the rate of orbital and near-surface reconfiguration. If orbital emotion, though not the province of protocols, threaded the decision-making in subtle but meaningful ways. Institutional language in the logs reflected an effective register common to moments of witnessing, a collective gravity, a restrained urgency, a tempered grief. This was not a single mind agonizing, but a mission's culture acting with the humility of archivists who know the value of the record and the fragility of the vessel entrusted to them. The voice of the documentation, the same voice that spoke of palimpsests and preserved echoes, translated procedural calculations into a plan emerged as synthesis rather than certainty. It was a hedge. A fairer-off safehold would be maintained, while expendable systems were dispatched to harvest the most perishable signatures. The mission would not commit the main vessel to the planet's inner corridor. Instead, it would push its disposable assets into the breach. Microprobes, each a compact lattice of desiccation-resistant reservoirs, impulsive capture nets, and velocity-tolerant inlet funnels, were prepared. High-gain antennae were retasked to prioritize telemetry bursts from those probes, and the ship's data pipelines were reconfigured. Concurrently, a second class of action was authorized: remote, non-invasive sensing at elevated resolution. Synthetic aperture radar modes were intensified on trajectories that kept the ship outside the densest ejecta corridor while still providing fine surface penetration. Multispectral. Hyperspectral passes were scheduled at phase angles chosen to maximize polarization signatures from reflective surfaces. Long baseline interferometry with one of the mission's separated relay buoys created virtual apertures large enough to resolve subtle. Execution was meticulous and tense. Microprobe deployment required a choreography of mechanical and computational steps. The probes were ejected on precise delta-V vectors to achieve the desired plume. Interception points. Their guidance suites were intentionally simple to lower failure modes, relying on inertial prediction with a short autonomy window for last-minute course corrections based on local optical tracking of high-contrast ejecta. The ship's thrusters performed minute counterbursts to maintain the protective standoff, and attitude systems prioritized sensor stabilization over long-term station keeping. Data priority. For a brief and cruel interval, the universe rebelled against careful plans. Even as the first microprobes began their descent profiles, a new series of quakes rippled through the planet. These were not the previous long-period tremors, but sharply focused ruptures that sliced along newly stressed faults. The shaking's amplitude increased, and the near-space environment thickened instantly as fresh ejecta was thrown skyward. Radar returns spiked into a noisy blur. Background particle counts climbed, and several microprobes were buffeted beyond control envelopes. One probe, struck by a shard the size of a small boulder, fragmented. The ship itself felt the planet's tremors as micro-impacts on its outer arrays and as minuscule torque shifts that the attitude control system compensated for with quiet efficiency. Protective algorithms throttled sensor exposure to avoid further damage, and the mission's archive mode moved into triage, preserve the highest value data first, then backfill. The decision to maintain standoff distance while sending expendables had paid partial dividends. It preserved core capability while harvesting what could be harvested. Yet it was not a clean victory. The loss of several probes, throughout the hours that followed, the mission's records show a rhythm of action, reaction, and reflection. Passive arrays recorded the planet shedding mass in spasms. LiDAR captured the sequential unroofing of cavities. Spectrometers traced a temporal decay of exotic emission lines as condensed material rained back into the newly reworked surface. Gravimetry revealed slumping basins and the sudden filling of subsurface voids. The plume that had once offered a thin window to deep sources had, in its initial convulsion, ejected the most accessible specimens. What remained would either be hammered into new. Beyond immediate collection, the decision had other consequences. The mission's capacity to retrieve intact, large-scale samples, the kind that would require the ship to commit to touchdown or prolonged hovering, was now compromised by risk profile and fuel constraints. The archival strategy therefore shifted toward maximal dissemination of what had been collected, redundant copies, distributed storage across the ship's long-duration tapes, and prioritized transmission to relay nodes destined for the long-haul courier back to human archives. The moral calculus favored distribution over reflection on the choice. The compromise between approach and withdrawal remained a theme in subsequent entries. The mission's log passed the decision not as triumph or failure, but as stewardship made under constraint. It situated the choice within a broader cultural frame. Field archaeologists had long argued over excavation's ethics, balancing the urge to reveal against the duty to preserve. Here the scale and stakes were different, but the principle similar. To approach is to risk damage and to potentially erase context. To withdraw is to preserve context but lose the highest resolution testimony. The mission, there is a small, human soft detail worth noting even in a narration that avoids single-person stories. The archival language adopted in the logs became almost liturgical. Entries were annotated with phrases that read like vows. Preserve context, minimize contamination, prioritize transient signatures. Those phrases bound technical procedure to ethical posture. They were a way of saying, in compressed technical terms, that the mission had adopted the humility of the witness rather than the hubris of an invader. In the face of a planet unmaking itself, there was a tacit recognition that the true priority was not the maximal sample. As the window narrowed into hours and then into the last measurable day, a different kind of urgency emerged. The planet's global oscillations lengthened into a low rumble, detectable at great distances. The atmosphere began to thin in regions where escape had been achieved through mass loss, and orbital fragments destabilized into decay, trajectories that would eventually cause many to enter and ablate in the atmosphere, or to be ejected entirely. The mission's telemetry traces at that stage read like a countdown annotated by data, the half-life of a newly produced ion, the expected time before a particular orbital node would. When the last of the primary microprobes returned its final burst of compressed spectra and imagery, the ship executed a conservative adjustment, an outward burn to place itself in a safer, more distant orbit while maintaining an observational aperture. That maneuver was a kind of surrender and a kind of triumph at once. It conceded that the planet would continue to rearrange itself in ways unpredictable on human timescales, but it ensured the survival of the observing capability. The sine qua non for any future rescue of data, whether by automated couriers or by follow-on missions, that the months that would follow, written in archive files and eventually in public reports, would analyze the trade-offs of those hours. Some commentators would argue that a bolder, close approach might have yielded richer returns. Others would commend the conservational ethic that preserved the mission's capacity to bear its burden home. The documentary truth is subtler. Under the constraints of signal delay, the unreliability of long-range authorization, and the observable acceleration of the planet's collapse, the chosen compromise produced a set of archives, damaged, incomplete, and yet irreplaceable. It captured ephemeral chemical states, samples of deep. The episode closes, not with a clean resolution but with a quiet insistence. Time, deep and indifferent, will unmake things and then re-encode them in fresh geologies. Human observers, brief in that vast ledger, can only choose how to bear witness. The decision made in those last urgent hours, to send disposable sensors into the breach while preserving the institutional capacity to remember, is an argument about what it means to be witnesses across epochs, to risk enough to gather testimony, to withdraw enough to carry it off, and to archive such that memory outlives immediate spectacle. The planet continued to shake, the ship continued. What does a silhouette between ruins mean when the ruins themselves have been catalogued as evidence rather than as a scene? The question arrived not as a hypothesis, but as a flicker across an imaging plane, a dark suggestion traced against a battered pane of reflected light. It was small within the scale of the planet's devastation, a shadow among shadows, and yet it had the power to reframe the ledger of observations. A world that had been read as geologic text now showed, in a few frames, a margin that might be a sentence written by agency. The vessel's decision to close the distance was therefore less an act of curiosity than a choice about witnesshood. Instruments could be held at arm's length and still record geometry, chemistry, and motion at a distance. But there is a threshold in observational practice where the qualitative changes, textures become legible, microgeometry becomes language, and the ephemeral signatures that molecular and mechanical processes leave behind can be harvested before the next convulsion erases them. To cross that threshold required a willingness to accept risk, to bring a calibrated curiosity nearer to a system. The cameras that first caught the dark forms did so in a cadence of pixels and frames that was almost indecently patient. High dynamic range optics interleaved exposures, gathering both the ground's cold specular glare and the faint thermal whisper of ejector-cooled surfaces. What arrived on the analysts' screens were sequences of silhouettes moving in the corridors between toppled terraces, blocky, angular outlines sliding along the shaded seams, occasionally pausing near narrow apertures where the light behaved oddly, as if passing through layered lattices. At coarse resolution, the technical response was protocol, a graded approach that combined magnification with caution. Imaging modes pivoted through a hierarchy. Wide-field cameras continued to sweep for context, mid-range optics tightened to produce depth maps, then a proximal array, originally reserved for safe standoffs, was brought into play to produce centimeter-scale texture maps. LiDAR point clouds thickened. Polarization cameras recorded how the light scattered. Hyperspectral apertures sampled reflected energy across narrow bands that could betray treated surfaces or alloys. All of this was done not in a single impulsive roll, but in what the aperture revealed enlarged the ethical stakes. Close-up imagery showed surfaces pocked by micrometeoroid strikes and veined with oxidation fronts, but there were also regions whose reflectivity differed from surrounding regolith with a consistency that suggested manufacture. Aligned microgrooves, regular perforation patterns at scales too precise for random fracture, and the absence of crystalline randomness in patches that were otherwise weathered. Where the shadows moved, the motion was not simply drift, it had directionality, pauses that implied sensing, micro-oscillations consistent with articulation. Multiple interpretations vied in the analytical suite. The most prosaic insisted on geology, coherent flakes of vitrified glass, thin laminae of impact, melted mineral arranged by gravitational sorting, or electrostatically levitated dust sheets whose dance could appear as intent at certain timescales. The more troubling possibilities, however, suggested agency in its degraded form. Maintenance servitors, autonomous caretakers, energy harvesting devices left in orbit by a culture now silenced, or routine robotic systems still executing long-forgotten loops in the absence of higher instruction. The deliberation itself was an act to be recorded. It was not drama in the human sense of arguments and raised voices, but a sequence of probabilistic assessments, threshold checks, and ethical framings articulated by the mission's protocols. Confidence intervals were computed for the likelihood that the moving forms were powered. Models of electrostatic force, residual internal energy, and environmental wind loading were cross-referenced against observed motion vectors. For each model, the expected footprint of human intervention, the chance that a thruster plume would change deposition patterns, in the architecture of that choice lay a particular kind of melancholic courage. To accept risk here was not to seek spectacle, but to accept a responsibility. Some signals, once gone, are irretrievable. The planet had already proved itself capable of abrupt rewriting. Fragments of alloy and traces of design geometry were ephemeral under the graceless hand of quakes and plumes. The archive that could be carried away, whether by the ship's telemetry or by expendable collectors, might be the only record beyond the next convulsion. To leave distance as a default was to decide, by inaction, which stories would be told and which. So the mission took a measured risk, not a reckless descent, but an economy of proximity. The ship's attitude control adjusted to maintain a tangential orbit that reduced the probability of encountering ejected fragments while allowing the proximal arrays to dwell near the site. Small sacrificial microprobes, previously prepared for plume sampling, were judiciously adapted for precision imaging and released on low-energy transfer arcs. They were not engineered as return-capable craft, but as ambulatory eyes, high-resolution camera suites, short-burst spectral samplers, and passive collectors designed to snap and what those microprobes captured deepened the tension between inference and reverence. Close-in sequences revealed chambers half exposed by recent ruptures, their interiors lined with repeating ribs and panel-like sheathing that folded into layered cavities. Where thermal gradients existed, thin filaments of still-melting material hung in suspended beads, forming strings that shimmered in polarization maps like a lattice mid-derangement. At the thresholds of these chambers, something akin to limb segments lay curled and partially embedded in slag. Their curvature and joints, yet even as the images suggested intent, they also whispered of degradation. Joints were seized with aggregates of vitrified deposits. Actuators, if that is what they were, showed corrosion gradients indicative of electrochemical attack by atmospheric components and charged particles. Surface films bore the remnants of lubricants polymerized into pale crusts. The artifacts did not move with the agility of active systems. Their motions were halting, sporadic, sometimes explained by thermal contraction or wind-driven oscillations. At other times, however, a microprobe's frame froze on a deliberate small movement, an appendage unfurling by the presence of residual power sources was probed indirectly. Passive electromagnetic listening detected narrow-band, low-amplitude carriers in bands where preserved capacitive storage or piezoelectric transducers might leak. These carriers did not resolve into structured signals. They were more like metabolic murmurs, the electrical equivalent of a heart's faint arrhythmic throb. Thermal modeling showed that certain nodes exhibited heat flux patterns that were not easily credited to geology alone. Cyclical microheating that could plausibly be energetic, dumping from batteries or from long-term radioactive decay. With evidence mounting but certainty still ungrounded, the mission's posture shifted toward documentation. First, minimal interference. Imaging sequences lengthened, polarimetric sweeps probed surface coatings without exposure to coherent laser pulses. Passive spectrometers recorded the composition of exhaled plumes as they passed through the newly exposed mouths of buried chambers. Microprobe flight controllers favored observation arcs that maximized visual and spectral coverage while minimizing physical interaction. When a probe's passive collector snagged a glassy bead in it, there was a narrative elegance in this minimalism. The mission did not seek to be an actor in the ruin. It sought to be a witness who left the scene as untainted as possible. But the ethical posture also admitted risk. Documentation without intervention can become complicity in erasure if the record itself is too sparse to permit future reconstruction. To hedge against that, the mission prioritized the capture of microstories, the layered grain structure of vitrified beads, the isotopic ratios in a plume's transient gases, the micro-etchings on a panel that might report maintenance cycles, or the sensation among the observing ensemble, the distributed human minds, and the algorithmic scaffolds that composed the mission's cognition, was a complex mixture of humility and acute vigilance. There was the technical satisfaction of seeing machinery, geological and possibly manufactured, reveal its intimate morphology to instruments that had been designed precisely for such fidelity. There was the quiet dread that some of those revelations would be gone by the next surge of shrapnel or by the settling of a newly tipped terrace. And there was a deeper emotional contour, the recognition that these marginal motions, these faint carriers, and as the close capture campaign proceeded, the cameras recorded new behaviors that would later populate long debates. In a narrow canyon between terraced platforms, a shadow uncoiled and then aligned itself precisely to a shaft of light, angling a facet toward the sun in a motion that could be read either as a passive response to differential heating or as the mechanical act of a sensor-seeking flux. A network of linked panels registered microvolt shifts when a plume passed, as if a distributed sensor array had been briefly stimulated and then left to bleed its charge. In the orbital frame, fragment clusters adjusted their attitudes subtly. Those images and measurements were not conclusions, they were invitations. The mission archived them with painstaking metadata, instrument modes, error bars, model fits, and alternative explanatory notes. Each file was a parcel prepared for future readers who might bring to it novel analytical tools, longer-term vantage points, or ethical lenses that could judge the choices made at the moment of decision. The decision to risk proximity thus closed into a meditation on responsibility. To approach had been to accept that knowledge is sometimes bought with exposure. But the approach had also been structured so that the cost, both to the mission and to the planet's fragile record, was minimized. The microprobes returned a handful of high-value packets before several were lost to newly rising ejecta and to shards unpredictably liberated by aftershocks. The ship itself retreated when models predicted increased probability of harmful debris intersections, preserving the capacity to transmit what had been gathered. In the archive that followed, those frames of moving silhouettes would become a hinge. They would support multiple narratives, a geological account that explained motion in terms of physics and chance, a technological account that inferred residual agency and long-lived automata, and a cultural account that read the patterns of manufacture as evidence of planning and intent. The mission, in its modest but profound way, had converted an ambiguous flicker into a series of legible traces. The risk had been calculated, the instruments had been used to their designed humility, and the resulting testament, what the future would make of these traces, remained unknowable. The camera had seen and the archive had held. In the long ledger of deep time, such a decision is a small, luminous thing, an act of attention pressed against the slow machinery of unmaking. The planet continued to convulse, new signatures flickered and vanished by the hour. The silhouettes between the ruins became, in the files, a refrain. Sometimes mechanical, sometimes geological, sometimes maddeningly equivocal. And a reminder that to choose to approach is always to choose how one will remember. 10. The moment of ending. What does the last light of a world tell those who watch? It is a question that sits between physics and mourning, a mode of inquiry where instruments and imagination must both be precise and gentle. The sensors had been reading a long decline, tremors that altered global modes, plumes that carried deep mantle fingerprints into the sky, orbital fragments that drifted like iron leaves. Yet even the most patient models had not prepared the mission for the kind of finality that unfolded. A choreography of collapse so swift and so absolute that it rewrote the ledger of what had been possible in the hour. At first, the change was geometric, not luminous. Fault networks that had yawned for days seamed together into a planet-scale rip. Plates that had been browed and brittle snapped along lines that had once been orderly. As the interior convulsions intensified, heat found new exits. The malted veins that had once bled in discrete flows became confluent. What had been isolated red tongues stitched themselves into a continent-spanning web. Infrared palettes saturated. Where sensors had previously recorded localized hotspots and episodic plumes, entire hemispheres now radiated as the atmosphere, thick with particulates and chemically charged by sulfurous exhalations, responded violently. Great cyclonic engines, already unstable, were driven into hysteria. Vortices that had once reorganized atmospheric mass over years now swallowed and regurgitated whole columns in minutes. The interaction of superheated gases and suspended ash produced pyrofoam, a luminous maelstrom of incandescent droplets and charged dust that caught and reflected light across vast scales. The sky, seen from orbit, became not merely cloud-laden, but a luminous loom that pulled fire across the planet's face. The spectacle had optical complexity. Photometers recorded an initial emergence of a white, searing flash, a sudden, enormous release of energy that widened into wavelengths a simple thermal model could not encompass. Spectra from the early phase showed signatures consistent with vaporized silicates, ionized metals, and recombination lines, indicative of high-energy plasma interactions. In the minutes that followed, the white bloom aged into copper hues and then into a bruised violet as high-energy particles, lifted from the lower layers, excited the upper atmosphere. The visible effect was the physical mechanics of that flare were layered. Deep reservoirs, pressurized and heated by mantle upwellings, experienced a failure cascade. Sealed voids ruptured in rapid succession, each vent amplifying the next. Where volatile rich strata lay adjacent to oxidizable metal deposits, exothermic reactions became a vector for explosive release, ejecting molten droplets and vaporized metal high into the column. The plume dynamics were not merely vertical. Lateral shock fronts propagated, forcing columns of gas to intersect with surface features, terraces, and engineered rims that had sheltered fragile artifacts. Instruments that had been built for patient accumulation now recorded a final, furious outpouring. Long integration spectrometers returned rare isotopic fingerprints, noble gas ratios that implied deep core material, sulfur isotope fractionations that could only have formed at very high temperatures, and metal vapor lines from elements normally sequestered below the crust. Particle detectors observed a surge of heavy ions, accompanied by complex organic fragments in low abundance, fragments whose presence raised anguished questions about what life there had been and what of it might have been consumed or transformed. There was also a mechanical reality. The planet's mass distribution shifted as material moved toward the surface and, in many places, vanished into space. Gravimetric mapping showed pockets of negative anomaly where entire slabs had been excavated and expelled. The redistribution of mass altered the angular momentum slightly. Tracking the planet's rotation revealed a tiny but measurable wobble. For the mission, this wobble was more than a data point. It was a visible rearrangement of the axis upon which every recorded habit of that world had once depended. Silence, for a while, followed the crescendo. The luminous flare dimmed not into calm but into an opaque shroud. A colossal dust veil rose and spread, a blanket that would obscure and scavenge for centuries. Light scattered through that veil with a prismatic cruelty. Some wavelengths were trapped and reddened, others filtered, and a few spectral lines, newly born of vaporized metals, shone through like remnants of an instrument's last note. The planet's silhouette, once crisp against the starfield, softened and then blurred into nothingness. Instruments that had fixated on geometric detail found only vanishing returns. So, amid the empirical facts, drifted the intangible questions that always follow a terminal event in a planetary system. If there had been habitations, where had they been? Could any refugia, deep subsurface caverns, protected orbital habitats, or resilient robotic systems have endured such a purge? The scientific stance could only enumerate possibilities without yielding certainty. Subsurface pockets insulated by depth and rock could survive for long periods. Microecologies could persist in thermally stable fractures. And for the mission itself, the technical aftermath was immediate and existential. Sensitive optics had been saturated, solar arrays particulate-coated, reaction wheels buffeted by micro-impacts as tiny shards struck at tangent velocities. Yet the craft's design for redundancy, redundant sensors, distributed storage, and conservative shielding had paid off. Critical systems remained functional, and a compressed, prioritized archive had been secured. In the silence after the dust rose, the ship resumed the work of recording, not the visible world, but what little the view allowed, spectral monitoring of the distance. The moment of ending had an aesthetic that was both brutal and revealing. The processes that destroyed also disclosed. The flare had unearthed deep materials and pushed into space compounds that otherwise would have remained sealed. The sacrifice of the planet's exterior as a stable record was matched by a sudden access to an interior ledger. Where previously only inference allowed the mission to reconstruct the planet's history, the explosion offered direct samples of the depths, albeit sampled at the cost of the surface's legibility. The duality was bitter and odd. From the vantage of deep time, the event was a punctuation like many others in planetary narratives, a rapid reorganization, a phase change whose long-term consequences would be measured in epochs. For the mission, and for the audiences who would later receive its tapes, the final flare was an ethical test. It forced the witnessing intelligence to decide what to save and how to save it in a world that was no longer a landscape but a dispersing cloud. The compulsion was archival, to gather what remained of trace evidence, to distribute it across redundancy. Whatever survival of biosystems, automatons, or cultural remnants might endure in the planet's bowels or in its dwindling orbital field would now live as records and probabilities rather than as certainties. Instruments could point to refugia with likelihoods and to orbital fragments with trajectories, but the silence remained, the planet's own reply. The last light had flared and then faded into a vast, indifferent cloud. The world ceased to be a clear object in the sky and became, instead, a data problem, a dispersed set of materials and signatures that the mission was 11. Data legacy. If endings compel action, then the recording of an ending becomes its own kind of survival. The ship's work shifted immediately from observation to preservation. The protocols that had been designed for methodical science, careful baselines, redundant cross-checks and conservative approach thresholds had to be exercised at a new tempo. The mission's archive, once a steady accretion of thoroughness, became a torrent of triage decisions, which high-fidelity records were irreplaceable, which could be compressed, which must be duplicated and dispatched at once. The first priority was the ephemeral chemistry. The plume had carried molecules from depths normally sealed by kilometers of rock. Many of these species were transient, isotopic states, excited ion complexes, and charged clusters recombined, condensed, or neutralized on timescales measured in minutes to hours. The mission reallocated bandwidth and storage to sample these fleeting signatures in the highest possible fidelity. Mass spectrometers were tasked to digest the plume's spectrum in overlapping sweeps, each sweep stored twice and transmitted in staggered bursts to minimize the risk of loss. where expendable microcollectors had survived the tumult. Second was the preservation of context. Scientific value depends not only on fragments, but on the threads that connect them. The orientation of an orbital fragment relative to a surface hub, the depth profile of a vitrified seam relative to stratigraphy, the timing of a seismic pulse relative to a particular isotopic spike. The mission treated this as its sacred duty. Every sample was archived with metadata that attempted to preserve its provenance in meticulous detail. Timestamps synchronized to universal atomic standards. Instrument states recorded with full telemetry. Phase out. A practical challenge complicated everything. Time lag. The nearest human repositories lay many light hours away. Real-time guidance from distant command centers was both impossible and undesirable. The ship had been delegated authority to act, precisely because waiting for permission would mean watching the planet erase the very things that needed saving. The mission's autonomy protocol therefore had to wrestle with moral priorities. It balanced the imperative to preserve the ship, and thus the archive itself, against the duty to gather perishable evidence. The chosen those relay nodes became the mission's most valuable lifeline. Pre-deployed buoys placed in distant stable orbits were designed as slow carriers for archival payloads. They had modest propulsion, robust shielding, and long-lived power budgets. The ship prioritized the stitching together of partial archives, a high-resolution spectroscopic sweep here, a collection of vitrified bead microtopographies there, a gravimetric time series elsewhere. Each chunk was relayed to different buoys, ensuring that the loss of any single carrier would not destroy the entire archive. The data was encoded in multiple There was, too, the hard question of what to prioritize. The mission's epistemic values guided its triage. Certain classes of evidence were deemed disproportionately informative, deep mantle isotopic ratios that could pin down the planet's internal dynamics, high-resolution imagery of patterned architecture that might bear on questions of agency and orbital mechanics, data that could reveal the disposition of any surviving artifacts in space. From a purely scientific perspective, these items promised the highest explanatory leverage. From a cultural standpoint, traces that hinted at agency, manufactured alloys, regular geometries at planetary scale, and the act of encoding was itself an ethical performance. Data was not a neutral payload, it was a testimony shaped by choices. Compression schemes, error correction strategies, and even the selection of which wavelengths to store all encoded judgment. The mission therefore logged not just the data, but the choices behind its preservation. Why a certain spectral window was sampled at high bit depth, while another was discarded at lower precision. Why a set of images was captured in polarimetry, but not in active LiDAR. Why a sample's microtopography received top priority and a second, otherwise interesting target. One striking practical innovation was the use of semantic redundancy. Instead of merely duplicating raw bits, the mission sent repeated representations of the same phenomenon through diverse modalities. A plume's chemical story, for instance, was archived as mass spectrometer peaks, as high-bandwidth spectrograph images, and as modeled compositional reconstructions. Physical textures were captured both as high-resolution photographs and as LiDAR point clouds. The rationale was simple and humble: storage media degrade, formats become obsolete, and future readers may possess analytical tools. There was also an awareness of cultural responsibility. If there had indeed been builders, story designers, or makers, beings who had intentionally shaped matter at planetary scale, then the fragments and the images the mission carried were more than data. They were the only remaining witnesses to someone else's existence. The archival ethic thus took on a quasi-archaeological tone. Samples that might be trivial from a purely geochemical standpoint were preserved because they could be part of a cultural narrative, a patterned groove, a repetitive microetchement, a vitrified seam whose microstriation hinted at too. Pragmatics shaped some painful decisions. Some microprobes had been lost, some images were corrupted by particle impacts, but loss did not equal failure. The mission's strategy of distributed capture had paid partial dividends, Even fragments salvaged from the worst affected sectors contained signatures that, when reassembled, allowed cross-validation. A high-resolution spectral slice captured by one probe could be corroborated by a microtopography sample from another. An orbital fragment's reflectance profile could be matched to a surface seam if time-synced metadata connected the two. In that sense, the archive was not merely beyond the technical and professional. The archive carried theological and philosophical weight. The mission's reports, written in calm, exact prose, nevertheless contained a strain of moral reflection. To witness a planet's death and to preserve its remnants is to confront the human tendency to imagine continuity, that cultural narratives will outlast catastrophe, that monuments are safeguards against oblivion. The record the ship prepared was an answer to a larger question. What responsibilities do transient intelligences have to their counterparts, dead or alive, across time and space? Technically, the archive's exit strategy was elegantly simple. Relay buoys were loaded and then scheduled for staggered departures, each set on trajectories that balanced communication latency and survivability. Some buoys would drift into deep space trajectories destined for salvage by slow courier vessels. Others were to remain in the local system, awaiting return missions that might someday retrieve their payloads and bring them home. The ship itself, carrying the master copy, executed a deliberate burn to place itself in a stable, distant orbit that maximized both solar income for power and data. There was a final, tender act to the archive, the inclusion of narrative context. Beyond raw spectra and point clouds, the mission prepared interpretive packages, layers of analysis, model runs, and carefully annotated alternative explanations. These companion files were not authoritative verdicts, they were interpretive scaffolds intended to guide future analysts through the labyrinth of plausible histories. They included Bayesian assessments, lists of null hypotheses, and margin of error calculations. The aim was not to foreclose debate, but to provide a map of the evidentiary terrain as it had been seen and reasoned about in the mission's archive was therefore both a scientific resource and an ethical artifact. It preserved the planet's last chemistry, its partial material traces, the disrupted geometry of its ruins, and the trajectories of its orbital detritus. It preserved, too, the procedural choices and the moral reasoning that had guided which things were saved. In doing so, it transformed the act of witnessing into an act of stewardship. What of the question of survival? The archive could not answer definitively whether any living systems persisted beneath the rubble or in sheltered niches. It could only enumerate probabilities. Subsurface pockets insulated by rock might retain temperatures and pressures amenable to survival for microbial life. Buried caverns, if sealed, might host chemoautotrophic ecosystems. Orbiting fragments, if containing intact drives or sealed habitats, might support tiny reserves of life. The mission archived environmental parameters needed to evaluate these possibilities. Thermal gradients. The final voice the mission left with its data was not triumphal. It was quiet and reflective, evidence gathered with care, stored with redundancy, and shipped away as testimony. The tapes, buoys, and master archives were designed as seeds of memory, durable enough to survive a long interstellar winter, yet flexible enough to be interpreted by minds unimagined at the time of their creation. They were, in the most literal sense, a legacy. In the long arc that stretches beyond any one mission, in the ledger of deep time, such a legacy matters because it is how one brief intelligence can honor another. To archive is to say, in technical and moral terms, that an existence matters enough to be remembered. The planet, smothered now beneath its own dispersing cloud, had ended its story in fire and dust. But its traces, curated by patient instruments and careful minds, were being carried outward into a dark space where memory might still find audience. The last light had flared and then vanished into the dull, vast fabric of the cosmos. 11. The archive and the absence. What does it mean to collect a world into packets, into binary folds and check some protected safes, and then to find that the world refuses the comfort of precedent? The mission's last act before distance and duty took over was archival, a deliberate, almost liturgical compression of the planet's testimony into formats designed to survive both physical decay and interpretive fashion. The resulting bundle was not a single file, but an architecture of memory, high-fidelity image stacks, time-tagged spectral sweeps, layered gravimetric series, LiDAR point clouds. The images arrived as light transformed into records. Cameras that had moved from coarse panorama to microtexture repeated their sweeps at multiple exposures, capturing the last readable mosaics of terraces and vitrified seams. High dynamic range sequences preserved both the cold, slate-grey plains and the sudden copper glows where molten veins had bled moments before the Great Flare. Each pixel was paired with a micro timestamp and a vector of observational parameters, phase angle, aperture state, detector bias, and the precise orientation of the imaging platform. Spectra accompanied the pictures like glosses. Hyperspectral cubes in visible, infrared, and ultraviolet were produced with overlapping windows so that no narrow emission line would be missed by a gap in sampling. Mass spectrometric fingerprints pulled from plume-skimming microprobes were annotated with capture velocities and inlet temperatures. Isotopic ratios that might betray deep mantle provenance were stored with measurement covariance matrices to prevent facile inference. Polarimetric data, the subtle way light scattered off aligned surfaces, was saved at multiple angles. Gravimetry and seismology were folded into the archive in the language of time. Long baseline integrations that had exposed whole planet oscillatory modes were chopped into epochs marked by the crescendo of seismicity and by the moments when mass redistribution made the planet's rotational wobble measurable. Those sequences were preserved in their rawness as well as in modeled reconstructions. Models were saved, not as final verdicts but as hypotheses, alternate inversions that allowed future analysts to see where priors nudged interpretations and where the data themselves pushed back. The file architecture paid as much attention to depth as to preservation. Where many data systems are content to save single, pristine copies, the mission's designers had anticipated loss and wrote for it. Each critical datum, every plume spectrum deemed time-sensitive, every high-resolution image of a suspected manufactured seam, every microtopography sample taken from a glassy bead, was duplicated, triplicated, and translated into multiple representational forms. A spectral sweep was archived as both raw detector counts and as a processed line list. A microprobe's captured volatile sample was recorded chemically. Dispatching the archive was an exercise in calculus and courage. The distance to any central repository meant that latency could not be folded into decision-making in real time. The mission therefore parceled the archive into prioritized strata. The most perishable, transient molecular ratios, charged clusters, excited ion species, was compressed and sent first, routed through nearest relay buoys with maximal bandwidth allocation. Next in priority were the high-value structural records, the geometry of ring-like formations. Polarization. Sending this material outward required more than bandwidth. It required trust in protocols that could not be human-checked at each step. Error-correcting codes and cryptographic integrity checks wrapped each packet like bandages. Embedded provenance chains recorded instrument calibrations and the versioning of onboard processing algorithms so that the archive would not later mislead by hiding the fact that a particular spectral feature had arisen from a firmware update or a particular imaging artifact had been corrected post-capture. In an act of prescience, the mission appended to each packet an interpretive skeleton, a careful enumeration of the hypotheses. The relays accepted their loads and made what little noise a deep space net will make. Beacons blinked in low-latency bursts, and packets were stitched into carrier waves that rode the local star's photons outward. The buoys were deliberate, Some took inner-system trajectories intended to be rendezvoused by nearer-term couriers. Others were set on far arcs optimized for long-term stowage and eventual retrieval. The master copy stayed aboard the ship in a hardened vault, a slow-burning seed intended to survive for centuries if necessary, while distributed copies set out along the lattice of what arrived at Central Command many light hours later had been shaped by 1,000 small choices made under pressure. It arrived as an argument more than as evidence, a collection of voices, each speaking through its own modality and bearing its own limits. The central nodes received the package and did what their protocols required: checksum reconciliation, temporal alignment against known ephemerides, and a furious cascade of cross-references. And that was where the archive met an absence that would not be reconciled by technical excellence. The coordinate tags, parallax-derived distances, and modelled orbital elements were compared against the entire extant corpus of astronomical records, survey mosaics, historical parallax catalogues, deep field accumulations, radio frequency logs, and the stitched heritage datasets that humans and machines had compiled for generations. The result was a blankness so total that it assumed a quality of rhetoric. The planet was nowhere to be found. The absence was not a faint omission, it was categorical. There were no prior detections within the expected observational horizons, no serendipitous reports from earlier deep surveys, no recorded transits, no gravitational perturbation traces in ancient astrometric datasets. The planet had left no genealogical mark in the databases that tracked bodies across epochs. If a planet could be said to have a paper trail, this one had none. It was as if a sentence had been spoken once and then removed from the book by an eraser that left no smear. For the institutional mind that received the archive, the implications cascaded like a set of formal problems. The technical reading came first, and sober: re-evaluate frames, test for coordinate transformation errors, recheck ephemerides, and validate the mission's timekeeping. It is an old and proper reflex to suspect a misalignment of frames before assuming the universe misbehaves. Deep time demands methodological humility. So the central systems reran comparisons in alternative reference frames, reprocessed images against barycentric time. None of the technical rereads produced a satisfying fix. The parallax signatures that the ship's sensors had recorded aligned internally. The nested triangulations between imaging, LiDAR, and gravimetry converged on a consistent set of spatial temporal claims. The error-correcting layers showed no evidence of corruption. The timestamps aligned to multiple atomic clocks. The crisis of faith shifted from the mechanical to the metaphysical. If the instruments had not lied and the archives were intact, then the cosmic ledger was incomplete in a more radical way. That incompleteness opened a ladder of speculative hypotheses, ordered by their evidentiary plausibility and by the gravity of their consequences. First came the simplest, an observational omission. The planet had been absent from earlier surveys because those surveys had not been sensitive in that patch of space at the times of prior observation. Surveys are patchy, deep field mosaics are stitched from many epochs. Perhaps the world had been missed because no instrument had ever looked with sufficient resolution, or because a transient veil, dust, gas, or a passing object had obscured it historically. That is an explanation. Next in line of probable explanations was a more technical possibility: coordinate misregistration across archival systems. Legacy datasets use a variety of celestial reference frames. Systemic offsets can create apparent disappearances if frames are misaligned. This possibility demanded no metaphysical leap and so stood as a sober first defense against more extravagant claims. If those possibilities failed, the hypotheses grew stranger. Could the planet be a transient assembly, a mass that coalesced and dispersed on timescales shorter than archival accumulation? A collisional agglomeration that briefly achieved planetary scale mass before being re-blown into rubble would be a phenomenon of scale but not of strangeness. Dynamics in dense ringed systems or in nascent planetary formation zones can produce ephemeral bodies. Yet the data suggested a body of internal differentiation and geological history, fissures, terraces, vitrified seams, that argued against. Another explanatory avenue implicated physics more directly. Was there a temporal boundary condition at play, a locale in the cosmos where causality or observational accessibility behave differently? In speculative cosmology, regimes occur where light cones twist and where records are selectively accessible. The idea is disquieting and, in most practical terms, untestable from a single dataset. Yet the possibility cannot be dismissed outright when the empirical cross-checks leave no ordinary recourse. Against all these technical and speculative constructions lay a quieter, sharper response. The absence itself became part of the data. The planet's lack of prior record was not merely a gap to be explained, it was a datum about the universe's capacity for surprise. To confront that datum is to confront human ways of being assured by precedent. The mission's archive, in other words, carried two truths at once: the presence preserved in the packets, and the broader absence that those packets revealed when measured against the social record of observation. Institutional reactions are, by design, conservative. The central repositories began a slow cadence of peer checks and validation epochs. They requested corroborating observations from other platforms and tasked survey arrays to re-image the coordinates across multiple bands. They convened analysts to test every plausible systemic glitch. This procedural insistence on verification is not mere bureaucracy. It is the only sensible way to prevent proclamation on the basis of noise. Truth must be made boringly robust. Yet the archival packets continued their outward journey regardless of delay. The mission's designers had anticipated the slowness of human adjudication and had chosen to act quickly where required. The archive had been sent. The seeds of the planet's testimony were already moving outward in a lattice of buoys and the ship's hardened store. Political and institutional processes, vexing as they are, could not alter the physical fact that an argument now existed in the world's data. Here was a planetary-scale record that, when compared to the broader astronomical corpus, revealed an unaccounted absence. Philosophically, the arrangement is a provocation. It unsettles the comforting assumption that the sky is a ledger, that every significant object is cross-registered and traceable. The universe, it suggests, can still deliver singularities, places that appear only when the right causal conditions are met, or records that are not continuous with the archival flows humans have built. The image of the planet existing, in a moment, becomes a metaphor, but also a methodological caution. The cosmos might not be a continuous tape. There is a moral angle to this as well. The act of sending the archive outward is itself an ethical judgment, a refusal to let the nature of the event be smoothed away in institutional caution. By broadcasting what it had seen, the mission stakes a claim for remembering. Even if Central Command were to withhold the release of the packets pending verification, the physical copies traveling across the void would ensure the possibility of testimony beyond immediate political or epistemic timidity. The archive was an intervention in the future, a commitment that something would be. The absence in the records became a narrative engine. It threaded through committee rooms and through the quiet, algorithmic inspections that run the modern cosmos. It forced questions that were not merely technical, but existential. What is the obligation of an observing intelligence when faced with an unheralded world? Is there a duty to announce and risk confusion, or a duty to withhold until certainty is established? The archive answered that by action rather than rhetoric. It had chosen testimony over the false comfort of consensus. At the edge of this unfolding bureaucratic drama stood a quiet anticipation. The packets, now en route, would eventually arrive at repositories where human and machine minds would comb them, cross-validate, and perhaps be forced to revision. The planet's non-presence in prior catalogues would be investigated thoroughly, and, in the process, the nature of astronomical surveillance itself would be interrogated. Survey strategies would be re-examined, prior nulls would be reprocessed with new attention. New questions about temporality, about the architecture of attention imposed by survey windows, and about the limits of registry. Yet even as institutions redo their math, the narrative voice of the mission, that impersonal, omniscient documentarian registering wonder and restraint, insisted on a final humility. The packets in transit were not verdicts, they were entreaties. They said, "Here is a world we saw, in all its last disclosure, weigh it carefully, test it, do not rush to mythologize, but do not let absence in older databases become an excuse for ignoring the radical empirical claim before you." What the central nodes and later readers would do with that entreaty remained a question for the next stage of the story. The mission's archive had done its work. It had preserved color and spectrum, geometry and gravimetry, motion and microtexture. It had dispatched testimony into a dark where memory must survive by redundancy and by fidelity. The cross-check that found no prior record did more than complicate the empirical claim. It gave the archive a new role. It turned it from a mere compendium of measurements into a challenge, to a community that believed itself to know the sky. There is, finally, a human tenor to the scene that deserves mention even in a narration that avoids the intimate tale of individuals. There is a small, communal feeling in the institutional mind that receives such absent confirmations, a blend of vertigo and humility, a re-examination of scale and of the shortness of human projects. A planet that may have once existed beyond the remit of the catalogary tradition pushes against the arrogance that believes the cosmos fully known. The archive's arrival and the discovery of the prior absence do not merely perturb technical systems, they nudge whatever sense of. In that nudge lies both peril and promise. Peril, because gaps in knowledge can tempt speculation that outstrips evidence. Promise, because anomalies are the spur to better instruments, to broader surveys, to thinking across longer intervals. The packets on their outward paths carried with them, then, a double freight, the testament of a vanished surface and the provocation to a future that must account for what past registers did not. Outside the immediate procedural entanglements, the archive closed on a softer note of preliminary resolution. The mission, having done what it could in the moment of dissolution, had acted with care. Its work would stand or fall to later scrutiny, but it had chosen to remember. That choice is the hinge on which the next chapter would turn, a world catalogued and sent, a cosmos that did not remember it, and the long, consequential conversation that must follow. The next part of the chronicle, the closing meditation that the archive would demand and that the community would soon compose, waits in the files sent to the distant centers. It will be a conclusion driven less by immediate certainty than by the patient reweaving of evidence, by the humility of refusal to overclaim, and by the human compulsion to tell stories that honor both presence and absence. The archive, already moving, will arrive and ask precisely that. What does it mean to know a world, and what is owed to the memory of one that seems to have existed stubbornly and magnificently? What does one carry away from a world that has finished speaking? Not trophies, not salvaged statutes, but questions folded into data, compressed spectra, point clouds, time-stamped seismic traces, a handful of glassy beads whose microtopography reads like calligraphy. The departure of the vessel was not a cinematic exodus, but a careful choreography of restraint, a series of small, precise acts that transformed immediacy into memory. The craft adjusted its station, engines whispering as they traded orbital momentum for a trajectory homeward, arrays that attract every convulsion shuttered in a ritual sequence to safeguard. There was a human quiet to that leaving. even when the human presence had been integrated with code, decision trees, and automated delegation. The collective aboard behaved as a body trained in the ethics of observation, methodical, slow, and almost monastic. Where once there had been the bright insistence of curiosity, now there was a different tension. The tension between what could be known and what must remain unknown. Eyes that had watched the planet's slow unmaking now watched their own instruments, counting files, verifying checksums, and annotating metadata with a that reverence took institutional form as well. The data packets left in the relay buoys and in the ship's hardened vault were not only technical payloads, they were ethical offerings. They carried not just numbers and images but layered narratives, alternative models of origin, confidence intervals, lists of null hypotheses, and careful statements of what the team did not know. These appendices mattered because the central question that would follow them outward was not merely a scientific one, but a moral and epistemic one: was the ruin the consequence of impersonal planetary mechanics, or the last visible evidence lay scattered on both sides of that binary. On the one hand, were the accounts of natural catastrophe, seismic modes that suggested a global convulsion originating in the deep interior, mantle plumes bearing primordial isotopes, and a final flare whose thermal and chemical signatures matched scenarios of chemical runaway and structural failure. Those records described a planet as a physical system in disequilibrium, where internal processes, the crystallization of an inner core, a mantle overturn, tidal forcing, could catalyze a rapid unmaking. On the other hand, were the patterns that refused to be smoothed by random models, rectilinear. The mission's narrative could not, in fairness to method, offer a settled answer. Documentary restraint required that each line of inquiry be weighed, contextualized, and left open. The rhetorical posture was one of calibrated uncertainty. It is a special kind of humility, rare in a culture quick to declare discovery, to report with equal vigor the possibilities that favored both natural and agentive explanations, to quantify confidence bands without reducing nuance to headline certainty. The archive thus read like an invitation rather than a verdict. Here are the textures, here are the probabilistic. That invitation reverberated beyond scientific circles. When the relay beacons passed the first bundles to the central repositories, committees convened in the slow, procedural way institutions do when faced with disruption. Independent teams reprocessed the spectral cubes and revisualized the LiDAR meshes. Survey archives were rescoured for missed detections, and survey strategies were interrogated for blind spots. Skepticism, the professional lubricant of good science, performed its work. Frames were re-registered, parallax solutions recalculated, coordinate transforms The archive shaped public imagination in ways both immediate and slow. Early releases, those carefully curated interpretive packages, provoked fascination and a landscape of speculation. Some voices read the rectilinear terraces as unmistakable monuments. Others cautioned that human pattern recognition is prone to false positives and that nature can, on large scales, sculpt form into order. The media cycle tried to turn ambiguity into a narrative that comforted or outraged. The institutions pushed back, releasing layers of data rather than simplistic claims. The mission's authors in practical consequences followed from that ethic. Survey programs were revised to include systematic deep time audits, a retrospective reprocessing of archival imagery with new algorithms, a metadata sweep of past nulls, and the adjustment of cadence in deep field monitoring so that ephemeral phenomena might be captured more effectively. Hardware design took a cue from the episode, prioritizing sacrificial microprobes and semantic redundancy. Storing the same phenomenon in multiple representational modes so that loss of one format did not render the observation nonsensical. A suite of policy proposals, nascent and still debated, recommended formal protocols for encountering. There was a deeper, almost pedagogical effect. The episode taught craft to a generation of instrument builders and archive designers, that patience in reading matters as much as speed in acting. The mission had chosen to record carefully, to send rather than to seize, to document context rather than to tear at the specimens. That posture propagated, it reshaped the default institutional assumption from collect now, ask questions later, to a more measured truth, that witnesshood itself can be an ethical act. If the ruin had been the last work of an intelligent, the philosophical aftershocks penetrated deeper. The absence in prior catalogues, that striking gap where no archival lineage could be found, forced reconsideration of what a sky survey really achieves. Survey mosaics are stitched from epochs, nulls are sometimes simply unobserved corners. The planet's failure to leave a prior trace became a data point in itself, an argument for the contingency of observability. The cosmos might host phenomena that only appear to a properly attentional gaze at particular epochs. It might also harbour ephemeral assemblies that, for a brief moment, achieve planetary coherence only to disperse or be consumed. Oh, there was a moral reckoning as well. The mission's choice to archive and to leave was bound up with humility about human capacity to intervene. The vessel had been capable of closer approaches. It had the technical means to sample at high resolution and perhaps bring back material. But some things, the mission decided, are best left to the record rather than to hands. Interference might erase microtopographies, contaminate isotopic balances, or trigger chain reactions that would destroy the very clues the scientists had come to read. The decision to withdraw with testimony instead of trophies was not the abdication of curiosity. It was that principle informed the shape of future plans. Follow-on missions would be designed not merely as extractors, but as custodians. They would carry suites of passive collectors, low-impact imaging arrays, and long-dwell archival buoys meant to act as time capsules. There were proposals for treaties, drafted in cautious technical language, to declare spaceborne ruins, style artifacts as cultural patrimony. Not the property of any one polity, but subject to protocols of preservation. In private and in public, the conversation had shifted from conquest to care. There was an emotional bottom note, too, one that instruments could not capture, but that human readers felt as they passed the files. The idea of a vanished maker, a mind that had once arranged matter at planetary scale and left behind only geometric residue and faint pulses, registered as a kind of grief. It was small and sober, a grief not for individuals but for the fragility of projects. Civilizations, like stars and planets, have lifetimes. They rise and create durable traces and then, by natural or self-inflicted causes, decline. The archive was a memory writing, an attempt to honor even as the ship receded. The planet's traces continued to ripple outward. Orbital fragments shifted slowly under altered mass distributions. The dispersing dust clouds scattered light in complex polarizations that would take decades to fully model. Seismology, passive and distant, continued to catch low-frequency hums that might, long after, reveal subsurface refugia. The mission left the area with files that asked for patient reading, spectral cubes to be reanalyzed with new calibration models, microtopographies to be matched with orbital fragment reflectances, and time series, whose correlation. And yet the question returned, persistent as tide, accident or intelligence. The logs did not collapse the ambiguity. They catalogued the evidence for both and made visible the costs of premature certainty. The world's destruction carried signatures that matched catastrophic internal failure. It also carried signatures whose order and specificity suggested intent. The mission left those fragments in other hands as a set of tasks rather than as an answer. Reprocess with independent pipelines, assay the deepest isotopic ranges, build models for artificial versus natural alignment at planetary. When the vessel finally turned wholly away, it carried with it more than data. It carried a mood, a quiet, shared gravity that complicated the exhilaration of discovery. The crew, collective human and machine conscience, was silent in a way that institutions sometimes are after a profound encounter, measured, reflective, and not prone to false narratives. They had seen a planet unmake itself. They had archived what could be archived. They had resisted the urgency to possess. Across the consoles, in the recorded biometrics, and in the annotation streams, the traces of that reticence remained. The final act of the mission, the tapes and packets would travel for a long time before a full reckoning could be offered. Analysts at various nodes would argue, model and remodel. Some would favor accident, others would trace the elegant lines of possible intention in the ruins and argue for a different kind of history. The tempo of rumor might outrun the tempo of verification. The slower, more careful work would eventually, one hoped, settle into a consensus that acknowledged uncertainty rather than erasing it. Meanwhile, the archive's multiplicity, its redundancy, its semantic layering, its interpretive appendices would do its work. It would allow future minds to... What, then, was the final story the mission could tell? Not a tidy narrative of raison d'être, not a sentence that closes a book. Instead, the mission left a landscape of questions, a field of possible truths, and a set of practices that preferred preservation over plunder. It left instructions about humility, that to encounter the remnants of worlds is first to listen, then to record, and only then to infer. It left, too, an ethical seed, the idea that in the face of planetary endings, the duty is not only to know, but to remember. The vessel receded slowly against the black, the planet's last light, a wan, complex smear in the eyepieces. Relay buoys drifted on trajectories intended to rendezvous with later missions. Data packets streamed like quiet emissaries into the deep. Silence settled over the bridge in that peculiar way. Silence does when a long task is complete. Not emptiness, but a charged absence that holds many possible futures. The mission's instruments had done their work. The archive would do the rest. The question that the crew took with them was not a problem to be solved in a week or a paper. It was a companion for the long work of interpretation, an insistence that the cosmos still had surprises, that the register of the sky was incomplete, and that human beings, brief readers of deep time, must choose again and again whether to act as scavengers or as custodians. They chose the latter and departed with the certainty that some stories, however well preserved, remain open. As the craft slipped into the dark between stars, carrying the loaded silence of the archive and the gentle ache of unanswered questions, it left behind a planet whose last acts had been both destructive and revelatory. The mission's final log closed, not with a solution, but with a lesson in scale and humility. In the universe, not every world is born to endure forever.